Yeah, is the screen visible? I hope it is visible. So today, our goal will be to complete gravitation as well as units and measurement, both the numericals as well as their questions, guys. Okay, so hopefully we'll try to complete them today. Whatever time it is possible, I'll just try to take that much time, guys. Right, so they are asking, so let us start with gravitation. It's the most important chapter. Definitely two questions will come from this chapter, guys. A maximum of three also can come. Two thought definitely will come. So let us first see with universal law of gravitation. Newton actually gave this law, and he said that every particle in the nature will attract every other particle with a force which is proportional to the product of their masses, inversely proportional to the square of the distance between them, and it will always act along the line joining the centers, guys. It is always acting along the line joining the centers, right? Each particle of nature will attract every other particle with a force proportional to product of their masses, inversely proportional to the square of the distance between them. If we remove the proportionality sign, we are going to get a constant called as universal gravitational constant, whose value will be 6.67 into 10 power minus 11, and dimensions will be m power minus 1 L cube t power minus 2. Right, so some basic properties you have related to law of gravitation. It is conservative in nature, it is always attractive, right? This expression is applicable for which masses, guys? The expression that we have taken, it is applicable for point masses as well as symmetrical masses, guys, right? Symmetrical masses, again it is not applicable for a rod. Again, directly you cannot do. If you are trying to solve for a rod, you need to consider integration part again, guys. So gravitational force between two bodies is due to exchange of imaginary elements again. So these are mediating particles, guys. They are mediating particles. Gravitational force will be mediated by particles called as graviton. They are going to have infinite range. It is a long range force, infinite range, and it is the weakest force, guys. It happens to be the weakest force. So the expression gm1 m2 by r square is applicable only for point masses or spherical symmetrical masses. It cannot be applicable for continuous all continuous masses, guys. So it is conservative in nature. They have infinite range. They are mediated by particles called as graviton. They are the weakest force. They are attractive, and it is also central force. It acts along the line joining the centers. One very important logic is these forces are independent of the medium, guys. Medium independent forces, gravitational force are. If you take two masses and place them in air, you take the same masses and place it in water or place it in some other liquid, right? They are not going to be, the gravitational force between the masses will not get affected because of the medium surrounding the masses or medium present between the medium which is present in the space between the masses. Again, that is the expression for gravitational force. So we have acceleration due to gravity. So what is acceleration due to gravity? In general, it is the acceleration produced in any object under the effect of gravitational pull of the earth or under the effect of gravity of the earth again, right? So if we consider we are placing a certain mass on the surface of the earth, let us imagine that we have something in this manner. We have something called a shell theorem, guys. So I am placing a mass on the surface of the earth. We have a theorem called as shell theorem. Let us consider earth has mass m and radius r. What does this shell theorem state again? Whenever an object, right, or you can consider whenever a point is outside the sphere. When I say sphere, it may either be a hollow sphere, which is also called a spherical shell, or a solid sphere, right? If the point of consideration is outside the solid sphere or spherical shell, then I can concentrate the whole mass of that sphere at its geometrical center. So if you see this point, when I say the mass is on the surface, this point is external to this sphere again. So can I concentrate the whole mass of the earth at its center? Yes, I can concentrate it here. Now both these masses will be separated by a distance r. Here you have small m mass, so I can concentrate the whole mass of the earth at its center. So what will I get? The gravitational force as g capital M small m divided by r square I'm going to get. So acceleration produced. So what will be acceleration produced in the mass? It is force acting per unit mass again. So it will be gm divided by capital R square. Yes or no? What is shell theorem stating? Whenever a point is external to the spherical shell or solid sphere, we can concentrate the whole mass of the solid sphere or the spherical shell at its geometrical center. So when you concentrate, these two will behave as point masses separated by a distance capital R. I can write force as G capital M small m by R square. Force is acting on which mass, guys? You can see there is some force acting on this mass, which is an unbalanced force. So because of this force in the direction of unbalanced force, we are going to have net force. In the direction of net force, we are going to have acceleration. So acceleration produced in the object due to the effect of gravitational pull of the earth will be called as your acceleration due to gravity, given by small g, guys. On the surface of any planet, it will be given as G capital M divided by capital R square. M can be mass of the planet, R can be radius of the planet, guys. If you want to write it in terms of density, guys, again, in terms of density, this is very, very important, guys. Either you can represent it in terms of mass or you can represent it in terms of density. In terms of mass, it is given as gm by r square. In terms of density, it will be given as 4 by 3 pi g rho into r. If we talk about density of the earth, it is 5.5 into 10 cube. Radius of the earth is 6,400 kilometers. Mass of the earth is 6 into 10 power 24 kgs. So these basic logics you should be certainly aware of. This is acceleration due to gravity. In terms of mass, you can write it as gm by r square. In terms of density, it should be written as 4 by 3 pi g rho into r. Right? Properties of gravitational force also we have seen. It is a central force. It is a conservative force. It is attractive in nature. Right? Then it is medium independent. These will be what we can consider. They are mediated by particles called as graviton. It is the weakest force. It has infinite range. Right? So these are basic properties of your gravitational force. I hope acceleration due to gravity as well as the gravitational force is clear. Then we have variation in acceleration due to gravity, very important case, right? When we talk about variation in acceleration due to gravity, g at a certain height above the surface of the earth will be given as g at surface into r divided by r plus h whole square, right? Or you can also write this is h is the distance from surface, beta. H is what? Distance from surface of the earth. Whereas I can also write g at a certain height as g at surface into capital R square divided by small r square. What is this small r? It is distance from center, guys. So from center, if I consider, right, g at a certain height will be inversely proportional to r square, guys. And whenever we are considering if height is very much less than r, then in that situation, I can write g at a certain height as g at surface into 1 minus 2h by r, although it is not always true, guys. It is true only when the height is very much near to the surface of the earth, or whenever the object is very much near to the surface of the earth. So basically the correct formulas are g at surface into r divided by r plus h whole square, or g at surface into capital R square divided by small r square. This will be variation at a certain height. In the same manner, variation at a depth, if I consider, guys, what will be the situation? Variation at a certain depth, if I say, it will be g at surface into r minus d divided by capital R. Or I can write d as g at surface into small r divided by capital R. So what is d here, beta? D is the depth from surface. Here h was height from surface. Here d is depth from surface. Again, small r will be anyhow distance from the center. So as you can see, inside at a certain depth means obviously it will be inside, it will be directly proportional to r, guys. So if I plot the variation, so these two things, please remember, this is true. G at certain height is g at surface into r divided by r plus h whole square. G at a certain depth will be g at surface into r minus d divided by capital R. Now, due to the rotation of earth also, there is some variation, and that variation due to rotation of earth will be given as g minus r omega square cos square lambda, where lambda happens to be the latitude angle. You might have studied about Tropic of Cancer, Tropic of Capricorn, right, in your schools again. Tropic of Cancer, it is passing to 23.5 degrees, 23.5 degrees latitude angle, we say. So latitude angle usually at equator, latitude angle will be 0. At poles, latitude angle will be 90 degrees. So what is latitude angle? Suppose if I say this is equator and point is taken on the surface. From the center of the earth to surface, this is the position vector of the point. whatever angle is made by the position vector of any point on the surface of the earth with the equator is called as latitude angle. So if the point is on the equator, latitude angle will become 0. If the point is on the poles, latitude angle will become 90 degrees. So that is the reason if we talk about G at poles, what is latitude angle? 90 degrees, guys. So what are we going to get? G at surface minus R omega square cos square 90. What is cos 90? 0. Cos 90 is 0 means obviously this total term will become 0. So will rotation of the earth affect the acceleration to gravity at poles? No, it will be gs only, guys. However, if we talk about g value at equator, so what will I get? Lambda value, you'll get it as 0 at equator. What will I get? G at surface minus r omega square cos square 0. Cos 0, it is 1. So I can write it as gs minus r omega square. Clear, all of you? Right? So will rotation affect the value of acceleration to gravity at poles? No. Will rotation affect the value of acceleration to gravity at equators? Yes. It is g at surface minus r omega square. Clear, all of you? Three things are very important. This formula, similarly this particular formula, and this formula, guys. Clear, all of you? Mass, however, is not going to change again. So if we just plot the variation of, let us see, if I plot the variation of g with respect to small r beta, what is going to happen? At the center, small r value will be 0. Center is lying inside. At a certain depth means, obviously that will also lie inside. So enter at center, g value will be 0, guys. So inside, how is it varying? Directly proportional to r. Because it is directly proportional to r, it will follow a straight line, guys. Inside, how will it vary? It will follow a straight line. Till where? Till surface, it is going to follow straight line. Beyond which, it is going to follow a square hyperbola, guys. So as you move from the center of the earth, what will happen to value of g? When you move away from the center of the earth, what is happening to g value? First, it is increasing linearly. Then it is going to decrease following a square hyperbola. If you move from surface, guys, from here, if you are moving from surface, either you move above, you see, g value will decrease. From surface, either you come inside, g value will be decreasing. As you move from center, g value first increases, then decreases. As you move from surface, whether you go outside or inside, g value will be decreasing only. At center of the earth, g value will be 0. Rotation of the earth will not affect g value at poles, it will affect g value at equator, guys. So g at poles will be maximum and g at equator will be minimum, guys. Clear? Understood, all of you? I hope it is clear. Okay. Then small heights you have anyhow seen, right? You can remember this, guys. If h is very much less than r, because we already got g at a certain height as g at surface into 1 minus 2h divided by r. So what we can write, g at certain height will be g at surface minus 2 into g at surface into h divided by r. G at a certain height minus g at surface will be 2 into g at surface into h divided by r. So this much change you are going to have, guys. So this is change in acceleration due to gravity will be minus of 2 into g at surface into h divided by r. So delta g divided by gs, you can consider it as minus 2h divided by r, guys. Again, that is valid only if h value is very much less than r. In the same manner, if you are talking about depth, guys, delta g divided by g at surface with the depth, if I consider, right, it will be given as minus of d divided by r. Again, for small cases, you can consider. So delta g divided by gs at a certain height will be minus 2h by r. This is called as fractional change in acceleration due to gravity. This is change in acceleration due to gravity. This is change in acceleration due to gravity. What is this, beta? This happens to be your fractional change in acceleration due to gravity. Percentage change, if they are asking, you will directly multiply it with 100. So here, in case of at a certain height, change is minus 2gs h divided by r. At a certain depth, if I consider, it will be minus gs into d divided by r, guys. Okay, this would be the change again. So these points you should be aware of. Clear, everyone?
Sir,
Yes, sir.
sir, can you increase the validity of exam? Means system
అరే
of
నువ్వు క్లాస్ వినకుండా నువ్వు ఇదేం చేస్తున్నావు రా భయ్? ఎందుకు
sir,
ఇంక్రీజ్
I had
చేయాలి చెప్పు
sent
నువ్వు?
you the
నేను
message, sir.
సరే, ఇట్ ఈస్ నాట్ ది టైమ్ టు ఆస్క్. నో, ఇట్స్ డన్, ఇట్స్
Yes,
డన్.
sir.
యూ కెనాట్ రైట్ నీట్ ఎగ్జామ్ ఆఫ్టర్ 5:20. హౌ మెనీ టైమ్స్ షుడ్ ఐ రిమైండ్ దట్? You just want to write the exam at your own will and wish. What is the prescribed time? You should write the exam at that particular point of time. Why should I increase? Tell me. There's no use of increasing, because it has been yesterday morning. I have told you that exam will be from 10:30 in the night to 10:30 in the morning. And it is not that you are spending so much time on physics. You are spending like 1.5 hour to 2 hours on listening to the class. 1 hour you are writing exam. That too not daily. 3 hours if you are not sparing, it is of no use then. I'll try to. Now I cannot say anything. Just because sir has increased the duration of exam once, it doesn't mean that sir will always increase the duration of exam. Right. So g at a certain height, you can use only this formula if the height is very much less than r, guys. Okay, so these are fractional changes and changes in acceleration to gravity. This is at a certain height h. This is at a certain depth d, guys. Clear all of you? Yes or no? Right. Now what they are saying is, suppose there is something called as weightlessness, guys, at equator. So when I just go back to the acceleration to gravity at equator, guys, you will get something in this manner. Yes or no? If I multiply by mass on both the sides, let us say if I'm multiplying by mass on both the sides, what are we going to get? I'm going to get g at m into g at equator. If I consider, it will be equal to m into g at surface minus m r omega square. So this is called as your apparent weight, beta. This is apparent weight. What is m into g at surface? This is your actual weight. And this will be centrifugal force at equator, guys. It is centrifugal force at equator. Now, if I just take an object, if Earth is rotating with its normal angular speed, guys, right, which happens to be 2 pi divided by 24 hours, or 2 pi divided by 86,400 radian per second. If Earth is rotating with its actual angular speed, if I take one object and place it at equator, this much will be the weight of the object, apparent weight of the object. Actual weight, to you all know, m into g at surface is the actual weight. If you take an object, if Earth is rotating with its actual angular speed, right, in that case, what is going to happen? An object placed at equator will experience this much weight. Suppose I don't want the object to experience any weight at equator. Weightlessness at equator, it is called as. Now, in this condition, I don't want it to experience any weight. So in this condition, what will apparent weight become, beta? Apparent weight at equator should become 0. So if Earth is rotating with its normal angular speed, in that case, any object placed at equator is experiencing some weight. But if I don't want the object to experience any weight at equator, then Earth should be rotating with some new speed, guys. So what is the situation for weightlessness at equator? Apparent weight of the object at equator should become 0. Earth will rotate with new speed, which will be given as root over g at surface divided by r. This will be 17 times the actual angular speed, guys. It will be how much? 17 times the actual angular speed. In the same manner, right? If angular speed became more by 17 times, the time period will get reduced by 17 times, which will be near about 1.4 hours. So if an object taken at equator is not experiencing any weight, it means Earth is rotating with a speed 17 times the actual angular speed, and time period will be reduced by 17 times, just in matter of almost 85 minutes, 84.6 minutes, or 1.4 hours. One day and one night will get completed. Instead of one day and one night getting completed in 24 hours, right, they'll just get completed in 1.4 hours, if Earth is rotating with the angular speed which is given as root over g divided by r. That is the case for here. When when omega of the Earth became root over g by r, g at equator will become 0, guys. Right? So gravity at equator is becoming 0. So duration of the day will become just 1.4 hours, guys. Clear, all of you? And usually the radius at poles, right, is less than radius at equator. So that is the reason G at poles will be more than G at equator, guys. 21 kilometers, somewhat more again. So as you move from pole to equator, radius is increasing. If radius is increasing, means acceleration due to gravity will decrease, guys. Okay. In the same manner, these already variations I have told you, right? This anyhow you can solve it, guys. Okay. Right, so two very important things where questions can be asked. As one will be gravitational force properties, the other will be acceleration due to gravity and its variation. Different cases, guys. G at a certain height, G at a certain height above the surface of the earth, G at a certain depth below the surface of the earth, due to the effect of rotation of the earth. What will be the variation of G with respect to distance from the center? First increases, then decreases. Right? What is change in acceleration due to gravity for small heights, or change in acceleration to gravity for small depth, generally for depth? Right? What is fractional change? Right? What is weightlessness at equator? These are very, very important situations again. I hope it is clear, all of you. Then let us talk about gravitational field intensity. So what is gravitational field intensity? By definition, it is force experienced by a unit mass placed at a point divided by the unit mass, guys. So if we talk about gravitational field intensity, what we will write, it is basically given as I bar. What will it be? It is force experienced by test mass. If I want to find gravitational field at a particular point, at that point I'll place a test mass. I will see how much gravitational force it is experiencing, and I'll divide it by test mass, guys. This will be the expression for gravitational field, Fm divided by m, force experienced by the test mass divided by test mass. In the same manner, if I want to find potential at a point, at that point again I'm going to place a certain test mass, guys, right? And I'll find out what is the potential energy it is experiencing at that particular point, again divided by test mass we can do. This is gravitational potential. If I want to find potential difference, then what will it be? I'll take change in potential energy divided by the test mass. These three are important cases, guys. Again, how do you find the gravitational field at a point? If I want to find gravitational field or potential energy at a point, at that point I'm going to place a test mass, guys. What will the test mass do? It is going to experience some force. The force experienced by test mass divided by the test mass will give us the field at that particular point, and whatever is the potential energy experienced by the test mass divided by test mass will give us potential at the point. So potential is nothing but the amount of work done in bringing a certain unit mass from infinity to a given point. What is potential difference, guys? It is the amount of work done in bringing a unit mass or a test mass from one point to another. What is potential energy? It is work done in bringing an object from infinity to a given point. What is potential? Work done in bringing a test mass from infinity to a given point. What is potential difference? Work done in bringing a unit mass from one point to the other. Clear, all of you? These are the situations that you should be aware about. The field will be given as force acting per unit mass. Potential will be given as potential energy divided by unit mass. Potential difference will be given as change in potential energy divided by unit mass. You cannot define potential energy at a point. You cannot define potential at a point. If you are defining potential energy or potential at a point, it has to be certainly with respect to some zero potential energy level or zero potential. In gravitation, we usually consider potential at infinity or potential energy at infinity to be zero. Clear? Understood, all of you? So there is some variation in field and potential also. But if we talk about variation in field and potential, right? For point masses, we can find out. For spherical shell, we can do. For point masses, you can do, right? In the same manner. Okay, so I'll just so already for point mass it is given, guys. So due to a point mass, how will the variation be? It will be minus gm by r square. Again, it is in vector form, but if I take only the magnitude in this, guys, for point mass, I'll get it as gm divided by r square. And as you can see, for point mass, field will vary as inversely proportional to distance from the point mass. And if we talk about potential, guys, for a point mass, it is given as minus gm by r. Potential will be varying as inversely proportional to distance from the point mass, guys. Right? And always remember, gravitational potential or gravitational potential energy will always be negative. Electric potential energy or electrostatic potential, if we consider, it may either be positive or negative, but gravitational potential will always be negative, guys. For a point mass, field will be gm by r square and potential will be minus gm by r. So field will be inversely proportional to r square, potential will be inversely proportional to r for point mass, guys. We have something called a spherical shell. We talk about spherical shell. Is there any mass inside the spherical shell? There is no mass inside the spherical shell, guys. So at an internal point, if I consider, what will be field value? Field inside will be 0. And what is potential? Potential everywhere inside will remain constant, guys. Potential everywhere inside will remain constant, which will be minus gm by r, same as that on the surface, guys. Again, these values you should remember again. What will be a field for a spherical shell? Spherical shell means hollow sphere. No mass inside means no attraction inside, means no field inside, guys. On the surface, if I consider, it will be given as gm by r square. Potential will be minus gm by r. So one point is to notice, potential inside everywhere you take, guys, it will be equal to potential at surface, which will be minus gm by r. Okay. So when will it be minus gm by r? If we consider potential at infinity to be 0. Now, whenever a point is outside, guys, outside they are saying. So whenever a point is outside, in that situation, what is going to happen? Whenever a point is outside the spherical shell or solid sphere, can I concentrate their whole mass at the center or not? Center is nothing but a point. So outside a spherical shell or solid sphere, variation will be same as that of your point mass, guys. So as you can see, what is the variation for field? Gm by r square, and potential is minus gm by r. So these will be the graphs for magnitude of field with respect to distance from the center and potential with respect to distance from the center. This is for point mass. However, if I take for a, sorry, this is for spherical shell, guys. If I consider point mass, so how is field going to vary with respect to distance? It is following inversely proportional to r square, which is your square hyperbola, guys. In the same manner, if we try to find out the potential variation, right? Potential, gravitational potential is always going to be negative, as I said. Gravitational potential is negative, it is following inversely proportional to r. It is going to follow a rectangular hyperbola, guys. So this will be the variations again. Clear, all of you? For spherical shell, inside no field, on the surface gm by r square, external to the surface gm by small r square. Right? For spherical shell, inside potential everywhere will remain constant, which is minus gm divided by capital R, which is equal to potential at surface, right? Potential outside will be minus gm divided by small r. These will be the variations for field and potential for a spherical shell. Let us talk about uniformly distributed solid sphere, guys. Now, uniformly distributed solid sphere means mass will be distributed in its volume. So there is mass present inside, guys. Right? So if we consider inside the solid sphere, it's a very important formula. Field will vary as gm by capital R cube into small. It is directly proportional to R. In the same manner, potential is a very, very important definition, guys. Right? The formula for potential inside the solid sphere is very important. Minus gm by 2 capital R cube into 3 capital R square minus small r square will be the field. At center, what will be the value of small r beta? At center, small r value will be 0. So if I substitute small r value 0, I'll get potential at the center as minus 3 by 2 times of minus 3 by 2 times of gm by r, which will be 3 by 2 times of potential at the surface. On surface, again, same, guys, same as that of your spherical shell only. Field is gm by r square, potential is minus gm by r. Outside, again, as I've told you, outside, whenever a point is outside the solid sphere, can I concentrate the whole mass at its center? Center is nothing but a point, so it will behave as a point mass. The same variation will be there inside the solid sphere, inside the hollow sphere, right? Which will be same as that of or similar to your point mass, guys. Clear, all of you? So as you can see, inside the gravitational field is directly proportional to r. Outside, it is inversely proportional to r square. So that is the reason if we plot the variation of field with respect to distance from the center for a solid sphere, guys, it will first follow straight line, then it will be following a square hyperbola. Whereas if you take the potential for your solid sphere, inside it will follow a parabolic curve, outside it will follow a rectangular hyperbola, guys. So outside it is inversely proportional to r. Inside, as you can see over here, G capital M divided by 2 capital R cube. Anyhow, for a given solid sphere, mass and radius will be same. Small r value will change, guys. So it is directly proportional to r square. Directly proportional to r square means it is going to follow a parabolic curve, guys. It will follow which curve? Parabolic curve. So if we talk about the potential for a solid sphere, inside it will follow parabola till surface. Outside it is going to follow a rectangular hyperbola. And as you can see, in case of a solid sphere, potential will be minimum at the center, which is minus 3 by 2 gm by r. Understood, all of you? So variations you please remember because they are very important. These are the variations as you can see. These are the variations for point mass, guys. These are the variations for point mass. One is variation of field, other is variation of potential. This is variation of field following square hyperbola. Potential is following rectangular hyperbola. Whereas these two are variation of field and potential with respect to distance from the center for spherical shell. Inside, no variation. Outside, square hyperbola. Inside, it is going to be constant everywhere, so it is a straight line. Outside, it will be rectangular hyperbola. For uniform solid sphere, inside it is directly proportional to r. So inside it will follow, field will follow straight line. And outside, anyhow, it is same as that of point mass, it will follow square hyperbola. For potential, this formula is very important, guys. Potential inside will be given as minus gm by 2 r cube 3 capital R square minus small r square. It is very, very important case again. I hope it is clear, all of you. These are the variations. To please do remember the variations for a spherical shell, for a point mass, for a solid sphere. Apart from that, you should also remember for a ring, guys. Now, when I consider a ring, you all know ring is similar to a circle again, right? So it is a planar object. So it can be placed either in xy plane or yz plane or xz plane. Let us imagine that we have taken a ring and we have placed it in yz plane, guys. We have taken a ring and placed it in yz plane. So what would be the axis of the ring? X-axis will be considered as the axis of the ring. They will ask you to calculate. So this will be your y-axis. This would be your z-axis. So where is the ring placed? It is placed in which plane, beta? It is placed in YZ plane. So what will its axis be? Passing through center and perpendicular to the plane. X-axis will be the axis, guys. So they'll ask you to calculate what will be the field and potential at axial point. Any point on the axis will be called as axial point. Let us imagine this is at a distance x from the center of the ring. Then in that case, the field will be given as gm into x divided by r square plus x square whole power 3 by 2, guys. And potential, if you consider, it will be given as minus gm divided by under root of r square plus x square. At center, if I consider, at center means x value will be 0. So what will field value be, beta, here? At center, field value will be 0 again because x is 0 means obviously field will be 0. What will be potential, beta? It will be minus gm divided by r. If I take very close to the ring, guys, now what is the meaning of very close to the ring? Same thing again. Very close to the ring means x value is very much less than r, beta. So in this case, what will be field? I'll get it as gm by r cube into x, and potential I'll get it as anyhow minus gm divided by r. So very close to the ring, it is going to follow a straight line graph, guys. Right? It is directly proportional to x. Away from the ring, it will follow a parabolic graph. And because it is varying with x, right? Field can have a maximum value and it can have a minimum value also. So what is the maximum value, beta? Maximum value. This is where these are very important cases. It will be at r by root 2. and the maximum value will be 2 gm divided by 3 root 3 r square. It's a very, very important case again. What is the value of field at any axial point for a uniformly distributed ring? G into m into x divided by r square plus x square whole power 3 by 2. Potential value will be minus gm divided by r square plus x square, right? And if you take at the center x value will be 0. So field will be 0, potential will be minus gm by r. Very close to the ring means this point is somewhere very near to the center. X value will be very much less than the radius, guys. So in that particular case, field will be G capital M by R cube into X, and potential will be minus Gm by capital R. So you can see here again, it is going to vary near to the ring. Near to the ring, it will follow a straight line. So very close to the ring, it is going to follow a straight line. Away from the ring, it is going to follow a parabola. So where will that field be maximum? It will be maximum at x is equal to r by root 2. Also here, backside, x is equal to minus r by root 2. How much will that be? 2 gm divided by 3 root 3 r square. Clear all of you? And potential anyhow will follow a curve something in this manner, guys. Right? So potential again will be minimum at the center. Right? In the same manner, you can take it something like this. Clear all of you? So these will be the variation of field and potential for a point mass, for a spherical shell, for a solid sphere, as well as for a ring. These four are very important, and all the formulas related to this you should be aware of, guys. I hope it is clear, everyone. Then we have something called as neutral point. Now, what is neutral point? It is also called as null point, guys. That particular point where field is zero will be called as your neutral point, or gravitational force experienced by a test mass kept at that point should be zero. So whenever we have two masses, right? If I assume P to be a neutral point, let us say P is a neutral point, guys. So for P to be a neutral point, what I can say? Net force experienced by a test mass placed at this point should be zero, or I can also consider the field at this particular point should be zero. So distance from R1, if I consider, so you can use what will R1 value be, guys? If I say entire distance is some smaller, what will be the location of neutral point? If they ask you to find R1 value, it will be R divided by root over M2 divided by M1 plus 1, guys. This will be distance from which mass? Distance of the neutral point from M1 mass. What is the distance from M2 mass, beta? Obviously, it will be R minus R1. That you can find. So neutral point is that particular point where the gravitational field will be zero. Or at that point, if you are placing any test mass, force experienced by the test mass will be zero. Clear, everyone? You can use this. M1 by R1 square will be equal to M2 by R2 square. You can use to find the location of the neutral point, or if the distance between the masses is given as R, then location of neutral point from M1 mass will be R divided by root over M2 by M1 plus 1. Clear, all of you? Now, as I've already told you about gravitational potential energy, guys, let me just very simple way of finding out gravitational potential energy, I'll tell you. Let us imagine if we have two masses, 2 point masses we are taking, M1 and M2. These two masses, let us imagine it is separated by a distance R, guys. By how much distance are they separated? Let us say these are separated by distance R. Then the expression for potential energy will be minus G M1 M2 divided by R, guys. So two masses we have taken, I got one pair. Like that, for n masses, if I consider, guys, for n masses, there will be how many pairs? There will be n into n minus 1 by 2 pairs of gravitational potential energy. So very basic point, if there are 2 point masses separated by distance r, then what will be the expression for potential energy? It will be minus G m1 m2 divided by r. If there are n masses, there will be n into n minus 1 by 2 pairs of gravitational potential energy, right? And what we can consider, suppose if there are 4 masses. So if there are 4 masses, how many pairs you are going to have, guys? You will have 6 pairs of gravitational potential energy. 4 into 4 minus 1 by 2, just 12 by 2, you'll get 6 pairs. What are those pairs if they are asking? Now, first mass will form pair with 2. Boy cannot form pair with boy, guys. Girl cannot form pair with girl. Huh? Right? A boy cannot marry a boy. A girl cannot marry a girl. Very bad situations are going currently in our country, right? In Supreme Court, there is a case pending for. Uh, ठीक है, let us leave those topics. Potential energy. If there are four masses, you are going to have six pairs of gravitational potential energy. One first mass, if I take, what are the pairs associated with first mass? One cannot form pair with one, guys. One cannot form pair with itself, right? One can form pair with two, one can form pair with three, one can form pair with four. These are the pairs associated with first mass. Now, two can form pair with one, but already the effect is considered in one. Two will not take. Can two form pair with itself? No, guys. Two can form pair with three, two can form pair with four. Three can form pair with one, but already effect is considered. Three can form pair with two, already effect is considered. Three cannot form pair with itself. Three can form pair with four. Four can form pair with one, already effect is taken. Four can form with two, four can form with three, four cannot form with four. So this will be the total energy associated with the system. If they are asking you to find energy associated with first mass, then you will consider only those pairs which include first mass. If they are asking energy associated with second mass, you will take only those pairs which contain second mass. If they are asking potential energy associated with third mass, you will take only those pairs which include third mass. Similarly, if they are asking you to find energy associated with fourth mass, you will take only those pairs which include fourth mass. However, if they ask you total energy of the system, then you will find out or do the algebraic sum of all the potential energies. N masses are there, there will be n into n minus 1 by 2 pairs of potential energy. So on the surface of the earth, potential energy will be given at earth's surface. This would be the potential energy minus g capital M small m divided by r. Now on the surface it is minus g capital M small m divided by r. If I take it to a certain height, guys, is the point external to the earth? Yes, so I can concentrate the whole mass of the earth at its center. Separation between the masses will be r plus h. So at a certain height, if I take, potential energy will be minus g capital M divided by minus g capital M small m divided by r plus h. Now, if I want to make the object move from the surface of the earth to a certain height without change in its kinetic energy, slowly I am making it move, guys. Then in that case, change in potential energy, directly you can write it will be mgh into 1 plus h by r. When is this case, guys? If I want to move the object, so if raised from a to a certain height from the surface of the earth, if you want to make the object move from surface to a certain height slowly, guys, not much change in potential energy, not much change in kinetic energy, then change in potential energy will be mgh divided by 1 plus h by r. This will also happen to be the work done in moving the object from surface to a certain height h without change in kinetic energy. Clear, all of you? Yes or no? Right, so this is important again. I hope it is clear, all of you. Please remember, when two masses are separated by distance r, expression for potential energy will be minus g m1 m2 divided by r. Right, and if you have n masses, there will be n into n minus 1 by 2 pairs of potential energy. Right, on the surface of the earth, potential energy value will be minus g capital M small m divided by r. At a certain height, minus g capital M small m divided by r plus h. So if you want to move the object from the surface to a certain height, you should do work against gravity, guys. And the work done against gravity will be change in potential energy, which is mgh divided by 1 plus h by r. If that h is very much less than r, guys, then I'll get change in potential energy as mgh. Clear, all of you? Yes or no? We also have something called as escape velocity, which is very important, guys. Again, escape velocity for different planets will be different, from different points will be different, guys. So what is that velocity? It is simply the minimum velocity that has to be given such that the object escapes the gravitational field of the planet or gravitational field of the earth. If it is escaping, means it will go to infinity, guys. So total energy should become how much? Zero. Right, whenever we are talking about satellite motion or motion of an object under the effect of gravitational force, Because gravitational force is conservative force, it is only conservative. If only conservative forces are acting, can we conserve mechanical energy of the system or not? Yes, definitely we can conserve mechanical energy of the system. So what we will do, for the object to escape from the pull of the earth or pull of any planet, it should go to infinity. So finally its energy should become zero. It means initial energy should also be zero only, guys. So what are we going to get from the surface? If I consider, it will be earth's surface. If I take the escape speed, will be given as root over 2 gm by r. In terms of density also it is taken, and in terms of small g also it is written, right? And what will its value be near the surface of the earth? It will be 11.2 kilometer per second. A very very important point. Suppose if you take the surface is something like this, object is present on the surface. If I want to escape it, either you project it vertically upwards or at an angle 30 degrees, 60 degrees horizontally. You project it at any angle, guys, irrespective of the angle of projection. If the object on the surface is given escape speed, then whatever may be the angle of projection, it will escape from the field of the earth. So as you can see, escape velocity is independent of mass of the object and direction of projection. If object is taken on the surface and it has been given a speed 11.2 kilometer per second, in whatever direction that speed may be given, the object will escape from the gravitational pull of the earth. Is that clear, all of you? So on the surface of the earth, it will be given as root over 2 gm by r, or root over 2 small g into capital R, which is 11.2 kilometer per second. From a certain height, if I say beta, escape speed will be given as root over 2 gm divided by small r again. It will be given as what? Root over 2 gm divided by small r. Or I can also write it as, if I just multiply into capital R square divided by small r square, you can write it as root over 2 into g at that certain height into small r beta. Clear, all of you? Understood or not, everyone? Bolo Vaishnav. Any
Sir,
problem?
sir, by the surface, do we mean the ground or the
No, no,
outermost
no.
layer of the earth?
Surface of the earth. Ground कहाँ से होगा?
Outermost layer of the earth.
Yes.
Okay.
Earth basically is flat, as you all know, right? We consider it to be in the form of a sphere, right? But in reality, it is flat, guys. So what is escape speed? Whatever speed that has to be given. It can be given from surface, it can be given from any point, guys. Right? Whatever speed that has to be given in order for the object to escape from the gravitational pull of the earth or the planet will be called as escape speed. From the surface of the earth, if you want to escape, it is root over 2 g capital M divided by capital R, or root over 2 small g into capital R, which is 11.2 kilometer per second. And escape speed doesn't depend on the direction of projection. If the object is taken on the surface, if you are giving a speed 11.2 kilometer per second, in whichever manner you may give, object will escape. And if you are giving it from a certain height h, or from some any point you are giving, then escape speed will be given as root over 2 gm by small r, or 2g at certain height h into small r, guys. Clear, all of you? Yes or no? I hope it is clear. Then we have three laws of Kepler, guys. One will be law of orbits, the other will be law of areas, and the third one will be law of periods, guys. What is first law stating? First law states that all the planets revolves around the sun in elliptical path. Sun will be one of its focus, guys. Right? As you can see, all planets are revolving around the sun only. Let us take, this is the situation. So sun is given on left hand side, guys. I usually take it on left. Sun is here given on right hand side. So I usually take it on left hand side and explain. So as you can see, at one point, it is very much nearest to the sun, right? At one particular position, the planet will be nearest to the sun. That position is called as perigee, guys, or perigee you can consider. One particular position, it is far away from the sun, guys, right? This is the farthest position. This is the nearest position. Nearest position is called as perigee, which is given as a into 1 minus e. Farthest position is called as aphelion, you can consider, or it will be farthest location will be at apogee. And what is that distance? Farthest distance will be 1 plus e, 1 a into 1 plus e, guys, or a plus AE you can consider. What is A here? A happens to be the length of semi-major axis, guys, and E will be eccentricity of the Earth. See, as you can see, it has two axes. This is one axis, this is another axis, guys. Which length is greater? This length is greater. Whichever axis has more length will be major axis. Whichever axis has length less length, that will be minor axis, guys. So here length of the major axis will be 2a. Length of semi-major axis will be a. Length of the minor axis will be 2b. Length of the semi-minor axis will be b only, guys. If you take from here to here, if I imagine, this distance happens to be b, which is length of semi-minor axis. Now, whenever it is moving closer to the sun, it will move with more speed, guys. The speed at perigee or perihelion is maximum. That speed will be given as g into mass of sun divided by a into 1 plus e divided by 1 minus e. And when it is far away from the sun, the speed will be minimum. The minimum speed will be at the aphelion or apogee, guys. It is given as root over 2 into g into mass of sun divided by a into 1 minus e divided by 1 plus e. Okay. At one position, it is nearest. That position is perigee. And how much is the distance? A into 1 minus e. At one position, it is farthest. That position is called as apogee. What is the distance? A into 1 plus e. Whenever it is moving near to the sun, it will move with more speed, guys. Always remember, whenever it moves near to the sun, it will move with more speed. So at the nearest position, speed will be maximum. At the farthest position, speed will be minimum. Maximum and minimum speeds I have given. So what is the ratio of minimum speed to maximum speed if they ask? It will be 1 minus e divided by 1 plus e. Clear, all of you? This is not required anyhow. Understood, everyone? So all planets revolve around the sun in an elliptical path with sun as one of its focus, guys. Right? Nearest distance will be a into 1 minus e. Farthest distance will be a into 1 plus e. Whenever planet is moving closer to the sun, it will move with more speed. So near the perihelion, it will have maximum speed, right? And at the aphelion or apogee, it is going to have minimum speed, guys. I hope it is clear. Second one will be law of areas, guys. What does it state? A planet sweeps equal areas in equal time intervals, right? So what we can write, guys? dA divided by dt will remain constant. dA by dt will remain constant. It is not VR by 2 basically, guys, right? Depends on different cases again. So here what we can write, dA by dt, it is also called as aerial velocity. It is written as RV sine theta divided by 2, which will be angular momentum divided by 2m. And always remember, in satellite motion or planetary motion, only force acting will be gravitational force, which is conservative in nature. So we can conserve the mechanical energy. And there won't be any torque about the sun, guys. So there will not be any torque, means angular momentum of the planet about the sun will remain conserved. So what is this dA by dt called as? Is also called as aerial velocity will remain constant. What is R here? It is position of the planet from the sun at any instant. What is V? Speed of the planet at any instant. What is theta? This happens to be angle between position vector as well as velocity vector. What is small m? It is mass of the planet, guys. What is it? It is mass of the planet. And what is your capital L? It is angular momentum of the planet about the center of the sun or about the sun. So always remember, there is no torque about the sun. It means angular momentum of the planet about the sun will remain constant. So what does second law state? Planet sweeps equal areas in equal time intervals. Aerial velocity will remain constant. It is given as RV sine theta by 2 or L divided by 2m. The third law happens to be your law of periods, guys. It is stating square of time period of revolution will be proportional to cube of semi-major axis, guys. So what we can consider? T square will be proportional to a cube, right? And if they are asking us to find the time period, basically it is given as, if you can just write it, the time period will be given as 2 pi a power 3 by 2 divided by root over g into mass of sun. Planetary motion is explained by Kepler's laws, guys. Whatever is planetary motion, same will be satellite motion. In planetary motion, whatever is the role of planet, in satellite motion, it will be played by satellite. In planetary motion, whatever is the role of sun, in satellite motion, that role will be played by Earth. Right? Usually we take satellite motion in circular path, guys. So here we will have radius. In planetary motion, we take elliptical path, so we took semi-major axis. So in satellite, sorry, in planetary motion, square of time period of revolution is proportional to cube of semi-major axis. If you take the same situation in planetary motion, in satellite motion, you will get t square will be proportional to a cube, guys. You will get t square proportional to a cube again. Clear, all of you? First law states, it is law of orbits again. All planets revolve around the sun in elliptical path, with sun as one of its focus. So what are the points to remember from first law? When it is near to the sun, it will move with more speed. At one point, it will be nearest to the sun. That point is called as perigee, a into 1 minus e. At one point, it will be far away from the sun, farthest from the sun. That point is called as apogee, which distance will be a into 1 plus e. When it is moving near, it will have more speed. When it is moving far from sun, it will have less speed. So at perigee, it will have maximum speed. At apogee, it will have minimum speed, right? And always remember, for planetary motion, we can conserve mechanical energy because the only force acting on the system will be gravitational force. And torque about the sun due to that gravitational force will be zero. Because there is no torque about the sun, we can conserve the angular momentum about the sun. As we can conserve angular momentum of the sun using that principle, right? He gave the second law called as law of areas, guys. Planets use equal areas in equal time intervals. dA by dt will remain constant, which is given as L divided by 2m. And third one is square of law of periods again. The square of time period of revolution of the planet around the sun will be proportional to cube of semi-major axis. Again, I'm saying planetary motion, satellite motion are similar. Whatever is the role of planet in planetary motion, satellite will play the same role in satellite motion. Whatever is the role of sun, that role will be played by Earth in satellite motion. Clear, all of you? Yes or no? The basic logic that we should remember is Earth satellite, which is orbital speed case, guys. So what is orbital speed? That speed that I have to give to the satellite such that it revolves in circular path around the Earth, guys. So at a distance, orbital speed will be given as root over gm into r. If you take near the Earth, guys, so near to the surface of Earth, it will be 7.9 kilometer per second. This is where on the surface of Earth. So on the surface of Earth, what will be the orbital speed or close to the surface of the Earth? If I want to revolve a satellite around the Earth, I should at least give a speed given as root over gm by r or root over g into small g into r, which is 7.9 kilometer per second, guys. Right? And at a certain height, if you take, or at any other point you take, it will be given as root over 2 root over gm by r. And what is relation between escape speed and orbital speed? Escape speed will be root 2 times the orbital speed. Whether you take near the surface or you take at any point, guys, escape speed will be root 2 times the orbital speed. Now, because it is performing circular motion, time period will be given as, you can see here, 2 pi root over r cube divided by gm. Near to the surface, if I take, it is 2 pi root over r by g, which is near about 84.6 minutes or 1.4 hours, guys. So from here, again, you can apply. From here, what we can say, beta? If I do square of time period, it will be proportional to cube of the distance of the satellite from the center of the Earth, guys. Clear, all of you? So whenever a satellite is revolving close to the Earth, it should have a time period 2 pi root over r by g, which is almost 85 minutes, guys, or 1.4 hours. Clear? Is that clear? Near about 85 minutes, we can say. So in order to ensure that the satellite revolves around the Earth in circular path, I should give a speed called as orbital speed, guys. On the surface, that will be root over gm by capital R. At any point above which is at a distance small r from the center, it will be root over gm by r, guys. Okay. Time period of revolution will be t square will be proportional to r cube, and as we have written over there, time period can be written as 2 pi r power 3 by 2 divided by root over g into, here you will write mass of earth beta. Small m is the mass of planet there. Here small m will be the mass of satellite. Capital M was mass of sun there. Here capital M will be mass of earth, guys. Clear all of you? Time period of evolution is important. In the same manner, energy is also very, very important, guys. If we talk about potential energy, if a satellite, let us say, this is the earth, guys, right? And I'm imagining that a satellite is performing circular motion around the earth. So it may perform in equatorial plane or it may perform in polar plane, guys. Let us say it is performing with some speed, how much? R. Right here you have satellite of mass m. This you can consider to be earth of mass capital M and radius capital R. Right. So what will happen? It will be moving under the influence of which force beta? Gravitational force. Let us say the sense is anti-clockwise. How will you find velocity at an instant? Along the sense at the given point, we are just going to draw a tangent. Right. If sense is clockwise, the speed would have been towards the right, guys. Clear, everyone? Now this speed will be your orbital speed, which is given as root over g capital M divided by small r, guys. Now you see, the point is external to the earth or not? So can I concentrate the whole mass of the earth at its center? Yes. So two masses are separated by distance small r now. So what would be the expression for potential energy? Minus g capital M small m divided by small r. Right. In the same manner, what is the expression for kinetic energy? It is g capital M small m divided by 2r. What is total mechanical energy? It is sum of kinetic and potential energy. You'll get it as g capital M small m divided by 2r, but negative, guys. So what we can tell here, the total energy will be minus of kinetic energy. And potential energy, if we consider, guys, it will be minus of k divided by 2. So if they ask you to find ratio of kinetic energy to potential energy to total energy, what will I get again? I can write uh, potential energy as, sorry, 2 times of kinetic energy you'll get, guys. Minus of 2 times of kinetic energy. So how we can write it as k is to minus 2k is to minus k. So I'll get it as 1 is to minus 2 is to minus 1, or I can write minus 1 is to 2 is to 1, guys. Now always remember, total energy of the sun and planet system will be negative. In the same manner, earth and satellite system will also be negative. Whenever total energy of any system is negative, guys, that system will be called as a bounded system. Whenever total energy of any system is negative, right, that system will be called as a bounded system, guys. So here the satellite is bound to revolve around the earth in circular path. There planet is bound to revolve around the sun in elliptical path. So whenever total energy of any system is negative, such system will be called as which system, beta? Such system will be called as your bounded system. What is an unbounded system? That system whose energy is positive. Zero also you can take, either zero or positive. So to unbound the system, if I say this is a bounded system, guys, I want to unbound it. I want satellite to move anywhere. I want to give freedom to this satellite. Instead of simply revolving in circular path, I want to give freedom to this satellite. So in order to unbound the system, we need to give some minimum energy, guys, to the object. That energy will be called as binding energy. And the binding energy of any system will be given as kinetic energy of the system, guys. So in order to unbound the system, we need to give a certain minimum possible energy that will be called as your binding energy of the system, guys, which will be equal to kinetic energy. Is that clear, all of you? Yes or no? So we have two types of satellite. One satellite which revolves in equatorial plane, the other satellite which will revolve in polar plane, guys. So the satellite which revolves in equatorial plane of the earth, from where to where? From west to east. This will be called as your geostationary satellite. I can also consider it is that particular satellite whose time period of revolution is same as that of time period of rotation of the earth, guys. Okay, and the height will be, from the surface it is 36,000 kilometers. So obviously from the center it will be 42,400 kilometers, which is also called as your orbital radius, guys. Distance of the satellite from the center of the earth is also called as orbital radius. For geostationary satellite will be 42,400 kilometers. Height from the surface will be 36,000 kilometers. It is that satellite which revolves in equatorial plane from west to east, and its time period of revolution will be same as that of time period of the rotation of the earth, which is 24 hours, and its speed will be nearly 3 kilometer per second, guys. The orbit in which it is uh, performing revolution around the earth will be called as geostationary orbit. Geostationary orbits are also called as parking orbits, guys. Not necessary again. Now, whichever satellite revolves around the earth in polar plane near to the poles, guys, that satellite will be called as polar satellite. So because it is near, revolving near, its time period will be almost like 100 minutes or 90 minutes or 80 minutes, like that, and its orbital radius will be almost same as that of radius of the earth. You can consider near about 6,500 kilometers to 7,000 kilometers they will be, and they are used for remote sensing, guys. Okay, all the prediction of rains, weather forecasting, all these are done by using polar satellites. Communication systems, what all global communication is taking place, that will be done with the help of geostationary satellites. Two types of satellites we have: geostationary as well as polar satellites. Not much necessary from need point of view to study binary star system, guys, so I'm not discussing binary star system. If you are getting any problem, we'll discuss it. Satellite motion can completely be uh, written in around 6 points, guys. Okay, I'll just satellite motion, if I consider, we can write it in near about 6 points again, or let us not talk, because one case is sufficient in satellite motion, guys. But major important case will be interstellar speed, guys. What will happen if the body is projected with a speed greater than escape velocity? Escape velocity means we know it will go to infinity, where total energy will be zero. Whereas if the object is projected with a speed more than escape speed, then the object will move into interstellar space, and it will move with some constant speed. There will be some kinetic energy finally, guys. Okay, and what will that speed be given as? It will be given as the speed of projection square minus escape speed square, guys. Speed of projection square minus escape speed square. Okay, clear? This is very, very important again. If a body is projected with a velocity greater than the escape velocity, it will go to interstellar space and it will move with some speed called as interstellar speed, guys. It is given as under root of the speed of projection square minus this escape speed square, guys. Let us say if the speed of projection, the given speed is n times the escape speed, then what will I get? I'll get the interstellar speed as, I'll get it as escape speed into under root of n square minus 1. So here n value should be greater than 1, guys. If it is less than 1 means it is less than escape speed. It will not be moving into interstellar space. So whenever speed is more than the escape speed, then in that case what is going to happen? Object will go to interstellar space and move with a constant speed called as interstellar speed. Its speed is given as under root of speed with which it is being projected square minus escape speed whole square. If the speed with which it is projected is n times the speed of escape speed, guys, then I can write interstellar speed as escape speed into under root of n square minus 1. Here n value should be greater than 1. If n value is less than 1, will it be moving into interstellar space? No, it is not going to move to interstellar space, guys. Clear, all of you? See, as you can see, if k value is less than 1, the maximum height attained, you can consider it will be r divided by 1 minus k square. We can solve the questions by using conservation of mechanical energy, guys. Right? However, I think these points are not that much essential again. One point which is essential is the last point, as you can see, guys. If usually gravitational force varies as inversely proportional to r square. If gravitational force is varying as proportional to r power n, then time period will vary as r power 1 minus n divided by 2, guys. It will be varying as r power 1 minus n divided by 2. So these are some basic points that you should remember in gravitation, guys. Clear, all of you? So it starts with gravitational force gm1 m2 by r square, properties of gravitational force. To the right side, I've explained you something called a shell theorem. Then acceleration due to gravity. What is the expression for acceleration due to gravity in terms of mass and capital G, in terms of G as well as density. Then variation at a certain height, variation at a certain depth, variation due to the effect of rotation. Rotation will not affect the G value at poles. Rotation will affect the G value at equator. G value will first increase and then decrease as we move from the center of the earth. Right? What is the change? What is the fractional change in G? Then, in order for an object to feel weightless at equator, Earth should be rotating with a speed which is root over gs by almost 17 times the actual angular speed. And time period will get reduced by 17 times, guys. Field intensity, how will you calculate? Is gravitational force experienced by the test mass divided by the test mass. Gravitational potential will be potential energy experienced by the test mass placed at that point divided by the test mass. We have seen the variation of field and potential for spherical shell, for solid sphere, as well as for a point mass, and we have discussed it for a ring also. These variations you should be aware. Then we have talked about the neutral point, that particular point where the resultant field will be zero, or the force experienced by test mass placed at that point is zero, will be neutral point. Potential energy, we have seen what is the expression for potential energy if two masses are separated by distance r. If there are n masses, what will be the number of pairs we have discussed. If you are taking the object from the surface to a certain height, how much work should be done? What is the change in potential energy we have discussed? What is escape velocity we have seen? Kepler's laws, three different laws we have discussed regarding planetary motion. Whatever is planetary motion, similar will be your satellite motion, guys. So same thing we have discussed. Two types of satellite we have: geostationary as well as polar satellite. And one last case that is very very important is your interstellar speed, guys. Whenever object is given a speed more than the escape speed, it will move into interstellar space and continues to move with constant speed called as interstellar speed. Also, if gravitational force is proportional to r power n, then time period will be proportional to r power 1 minus n divided by 2. Clear, all of you? Yes or no? So this is the first part of gravitation. Let us discuss the questions. So you can take an around 10-minute break and come back by 11 o'clock, or maybe by 11:05. And try coming back, guys. Clear, all of you?
So
Yes, sir.
so we consider the equations of intensity and potential to be negative because it is attractive in nature, because the gravitational.
It is all depending on sign convention. Yeah, mostly because they are attracting, we take it as negative.
Understood, sir.
So you can take a 10-minute break, guys. You can come back by 11:05 using the same link. We'll do questions of gravitation. Hopefully, we'll try to complete gravitation now, and probably units and measurement in the evening if possible, depending on the situations, guys. Right, any doubt as of now, all of you? So that was the review of gravitation, right? We have tried to complete the gravitation. Next, we will do questions. Through questions, you can understand much more things about gravitation. So we'll meet in 10 minutes of time, right? So, chalo, take care, everyone. Join back. I'm just keeping it on mute, and I'll just turn off the camera. Please join back in 10 minutes of time. Thank you. So welcome back, all of you. Am I audible, everyone? Am I audible, all of you?
Yes, sir.
I hope the board is visible. Let us solve some questions of gravitation, guys. Okay. So they have given four similar particles of mass m and r orbiting in a circle of radius r in the same angular direction because of the gravitational attractive force. The velocity of each particle they are saying. Let us say they are orbiting in clockwise sense. How will you find velocity at any point? Along the sense of rotation, right? At the given point, you are just going to draw a tangent. You are just going to draw a tangent, guys. Right? So whenever they are performing circular motion, what should be there? Whenever objects are performing circular motion, there should be centripetal force directed towards the center. Can it exist on its own? No. Right? What is the situation? It cannot exist on its own, guys. It should be provided again. So there are four masses, something like this on the circle again. You can take, guys. So they are something in this manner. Right? The four masses have been placed on the circumference of the circle. So let us imagine this is our first mass, this is second mass, third mass, and fourth mass. So firstly, what I will do, what will first mass do? I want to find the force acting on first mass. So what is the force acting on first mass, beta? It will be force acting on first mass due to second mass, force acting on first mass due to third mass, force acting on first mass due to fourth mass. It is called as principle of superposition, guys. Whenever they are asking us to calculate force acting on any mass, it will be vector sum of forces due to all the masses present in the system. Please tell me, what will third mass do? Third mass, is it going to attract or not? This is the force exerted by the third mass on the first mass. Now you see how much is this distance? This distance is r, this distance is r, this distance is r, this distance is also r. So automatically, what will this distance become, beta? Will it become root 2r or not? Yes, it is going to become root 2r again. So what will the fourth mass do? It will again attract this force on first mass due to fourth mass. What will second mass do? It will also attract, which is force on first mass due to second mass, guys. So these are the three forces that we have. If you talk about the magnitude, what is F12? You will get it as G into M divided by, what is this distance, beta? If this is R, this is R, automatically will this become root 2 times of R or not? This will also be root 2 times of R. So what will I get? G small m divided by root 2 R whole square, which I will get it as Gm square divided by 2R square. Now same will be the magnitude of force on 1 due to 4, guys. So what is force on 1 due to 3? You will get it as Gmm divided by, what is separation between the masses, beta? 2r whole square. No. So what are we going to get it as? Gm square divided by 4r square you are going to obtain. Yes or no, everyone? Now, see, these two are same in magnitude. F12 and F14 are same in magnitude and they are perpendicular to each other. So what is the resultant of F14 and F12, guys? If we talk about resultant of, let us say it is F dash. So I can write it as under root of F12 square plus F14 square, guys. Which turns out to be, how much will I get? Gm square divided by 2r square whole square plus Gm square divided by 2r square whole square. Which I will get it as root 2 into Gm square divided by 2r square. So the resultant of F12 and F14, how will it act? The resultant of it will act in this manner only. This is F dash. Now you see we have two forces. F dash is the resultant of F12 and F14, and you have F13. Both are acting in same direction. So what is the net force experience? Because they are acting in same direction, I can write it as F dash plus F13. So I'll get it as root 2 Gm square divided by 2r square plus Gm square divided by 4r square, guys. So what we can do, we can take Gm square divided by 4r square common. So here anyhow in denominator you are getting root 2. So in denominator if you are getting root 2, you will get this as 2 root 2 plus 1 beta. Sorry. This is gm square by root 2 r square, no? So what I'll get, if I want to get root 2 in denominator, it will be 2 root 2 plus 1. This is the net force going to act on any mass, guys. Clear all of you? Force acting on any mass will be vector sum of forces due to all the masses present in the system, guys. So net force acting on any mass you may take, it will be gm square divided by 4r square into 2 root 2 plus 1. Now this force will be necessary in providing the necessary centripetal force, guys. I can equate this to m into v square divided by what is the radius in which they are performing circular motion. You can take it as r, guys. So what will be the net force here? Gm square divided by 4r square into 1 plus 2 root 2 I can write will be equal to mv square divided by r. In place of capital M, I took small m. In place of small r, I took capital R, guys. I've just taken few things reverse again. M and square will also get cancelled out. So if I square root on both sides, I'll get it as 1 by 2 root over gm by r 1 plus 2 root 2. This will be the speed of any mass, guys, which are performing circular motion again. Clear all of you? Whenever object performs circular motion, there should be a certain force directed towards the center called as centripetal force. Can it exist on its own? No, it has to be provided. So who will provide the centripetal force on each mass? The resultant gravitational force will provide the necessary centripetal force for each mass. So I have taken first mass, guys. Try to calculate the resultant force acting on first mass. We got it as gm square by 4r square into 2 root 2 plus 1. This force will now provide necessary centripetal force. Clear, everyone? I hope it is clear, all of you. And a point P lies on the axis of a fixed ring of mass m and radius r at a distance r root 3. So what is x value given here, beta? Root 3 into r from the center. The particle starts from point P and reaches point O under gravitational attraction between ring and particle. The speed of the particle at a distance r from the center they are asking. So initially it is at root 3 r distance. Finally, where will it be, beta? It should be at r distance. Let us say particle is starts at P. Let us say it is starting at rest, guys. Initial velocity, let us imagine it is 0. They're asking what would be our final velocity. So whenever you take a ring and a mass, this mass will only be under the influence of gravitational force, guys, which is conservative in nature. So because it is conservative, only conservative forces are acting, I can say initial energy will be equal to final energy. Okay, so initial kinetic plus initial potential will be final kinetic plus final potential. And how we can write potential energy? We know potential is given as U divided by M. So what we can write potential energy as? I can write it as M into V, guys. What is initial kinetic energy? It is starting at rest initially, so it will be 0. Now please tell me what is initial potential energy? Initially it is at a distance root 3r. What is potential at an axial point? We know potential at an axial point, if I consider, how much is it given as, beta? Minus gm divided by under root of r square plus x square. So initially where it is? At a distance x is equal to root 3r. So if I solve for this root 3r, if I take, you will get 4r square. Under root of 4r square will be 2r, guys. So what will I get here? Minus g capital M small m divided by 2r. Finally, you can say half m into v final square plus what is final potential energy. Finally, it is at a distance x is equal to r, guys. So if I substitute x is equal to r, you will get 2r square. So I'll get it as minus g capital M small m divided by root 2 capital R. What we can cancel out? Small m, small m, small m can be cancelled out. So what are we going to get here? V square divided by 2. If I send this on the other side, I'll get gm divided by root 2r minus gm divided by 2r, guys. Yes or no? So what we can take? Let us take gm divided by 2r common. So in first term, what I'll get? Root 2 minus 1. So from this, what we can cancel out now? So v square. Again, very good questions, guys. What are we going to get here? V square value, I'll get it as 2 and 2 will anyhow get cancelled out. So Vf square value, I'll get it as Gm by R into root 2 minus 1. So what will be the speed at a distance R from the center? Root over Gm by R into root 2 minus 1 will be the speed at a distance R from the center, guys. Clear all of you? Right? So whenever questions are asked in gravitation, blindly you apply conservation of mechanical energy, because the only force acting will be gravitational force, which is conservative in nature. And if only conservative forces are acting, we can conserve the mechanical energy of the system. Initially, the point was at a distance root 3r. So due to the effect of gravitational pull of the ring, it will move towards the center. When it is at a distance r from the center, what is the speed they are asking? So because it is moving only under the influence of gravitational force, we can conserve the mechanical energy of the system. Is that clear, all of you? I hope it is clear. Two masses m1 and m2 are placed at a distance d apart. The minimum speed with which a particle of mass m projected from a point midway between, so as to escape from infinity. Again, very, very important case, guys. I have two masses, it seems. What is separation between the two masses? D is the separation between the two masses. Yes or no? You can consider this mass to be m1, you can consider this mass to be m2. From the midpoint, you have a mass small m. Now it has to be projected. I don't know what is the speed. Let us assume it is being projected with speed v. So as to reach infinity, guys. So at infinity, we will consider potential energy to be zero, kinetic energy will also be zero. So again, it will be moving under the influence of gravitational force of m1 and m2. Which force is acting? Only gravitational force. So what we can do? We can conserve the mechanical energy of the system. So initial potential plus initial kinetic should be final potential plus final kinetic. So finally, it is moving to infinity, 0. This also 0. Now how many masses we have? 3 masses. How many pairs are we going to get, Vidna? 3 into 3 minus 1 by 2. 3 pairs we are going to get. First pair will be between these two. So what will be the expression for potential energy between these two? Minus G m1 small m divided by separation between them will be d by 2. Then between these two, what is it? Minus G m2 small m divided by separation between them d by 2. Then between these two, guys, what will it be? Minus G m1 m2 divided by d plus half mv square should be equal to what? 0. Clear, all of you? So from this, what we can take now? I can write this as, I'll get it as minus 2 g capital M's 1 small m divided by d minus 2 g capital M2 small m divided by d minus g m1 m2 divided by d plus half mv square should be equal to 0. Yes or no, everyone? So what we can take now? Minimum speed with which a particle of mass m projected from a point midway between the two masses so that it escapes to infinity, they are asking, guys. So what we can consider now? Now finally, okay, finally this mass has gone to infinity. Yes or no? This mass has gone to infinity. But these two masses are still kept at some separation only or not? Yes or no, beta? Initially this is the situation. Finally this mass went to infinity. But still these two masses are kept at some separation only or not? The final potential energy of the system will not become 0, guys. What will it become? Final potential energy? It will be minus G m1 m2 divided by d. So what we can cancel out now? You can cancel out this and this. Okay, so what are we going to get? Plus half mv square should be equal to what? 0. So from this I can write minus 2g small m divided by d, you can take common. I'll get m1 plus m2 should be equal to minus half mv square, we can write. So from this again, minus and minus will get cancelled, m and m will get cancelled. So implies, what will I get the value of? So we'll get 4 times again, guys. What will v value be? It will be 2 times of root over g by d into m1 plus m2. Is that clear, everyone? Understood or not? 2 times of g by d into m1 plus m2. See, very simple logic. Initially, you have 3 masses. Okay. So minus g m1 m by d by 2 minus g m2 m by d by 2 minus g m1 m2 by d. Finally, this mass has gone to infinity. So potential energy between these two masses at infinity will be 0. Between these two masses will be 0, but there will be potential energy between m1 and m2. That is why I've written final potential energy as minus g m1 m2 by d, guys. Understood, all of you? Very important case. Kepler's second law is based on what? dA by dt is L by 2m. L is nothing but angular momentum of the planet about the sun, which will always remain conserved. So it depends on law of conservation of angular momentum, guys. Clear, everyone? Yes or no? Kinetic energy of a satellite in an orbit depends on what it seems. What is expression for kinetic energy? It is G capital M small m divided by 2r. Is it depending on mass of satellite only? No. It is depending on radius on orbit only? No. Is it depending on mass on central planet only? No. It is depending on all mass of the planet, mass of the satellite, and radius of the orbit. It depends on all things, guys. You can consider all mass of satellite, mass of central body, and radius of orbit. Clear, everyone? Next question, if we see amount of work done in bringing three particles, each of mass 0.1 kg, slowly from infinity. Infinity means what is initial potential energy? 0. Right? And I have to bring it to form a equilateral triangle, guys. If I say I want to bring the masses somewhere from infinity to form a certain equilateral triangle like this, guys. So in this situation, what are we going to get? As you can see, I want to bring three masses. All are equal masses only. And slowly means without change in potential energy. So three masses have to be brought, right? And what is the distance again? You can consider A will be the distance. So initial potential energy is 0 because initially it is at infinity. Finally, what is it, beta? Finally, if we consider, I have three masses again. So what will be, how many pairs are we going to get for potential energy? Three pairs. What are those? Minus g m square divided by A between these two, plus minus g m square divided by A between these two, plus minus g m square divided by A between these two. So overall, I'll get it as minus 3 m square divided by A. So they're asking amount of work done in bringing three particles, each of mass 0.1 kg, slowly from infinity to the vertices of equilateral triangle. So all these will move under the effect of gravity. So always remember what is work done by gravity, guys. Work done by gravity here or gravitation, they will be coming towards each other with the help of gravitational force. Which type of force it is? Gravitational force is a conservative force, guys. So work done by gravitational force, as you all know, it is minus delta u, which I can write it as u initial minus u final. Is anyhow 0, I'll get it as 3 m square divided by A. And if they ask you work done by external agent, guys, as I said, work done by external agent will be delta u, which I'll get it as minus 3, or I can write, if I want to add one more step, can add, it is u final minus u initial, which is minus 3 m square divided by A. So I'll just find out what is the value of 3 m square by A, which I'll get it as 3 into 6.67 into 10 power minus 11. M value is 0.1 whole square will be 10 power minus 2 divided by, what is the side? 0.2 meters. I can write it as 0.2 only, anyhow. Right? So what will this become, guys? 3 into, this will be near about 20. 20 by 2 you will, 20 by 0.2 you will get, guys, which is 20 divided by 0.2 into 10 power minus 13. 0.2 can be written as 2 by 10. So it will become 200 by 2, which is 100 into 10 power minus 11. So I can 100 into 10 power minus 13. 1 into 10 power minus 11 joules will be the answer. If they are asking us to find work done by gravity, the answer will be 1 into 10 power minus 11. If they are asking us to find amount of work done by external agent, then the answer should be minus 1 into 10 power minus 11 joules. Clear, all of you? If they are moving under the effect of gravity to occupy an equilateral triangle or to form an equilateral triangle, then work done by gravitational force will be 3 m square by A. Right? But if there is some work done by an external agent, guys, We are bringing these particles. So work done by external agent will be taken as delta U now, which is minus 3 gm square divided by A. If I assume we are work is done by external agent, answer should be minus 1 into 10 power minus 11 joules, guys. Clear, all of you? I hope it is clear. And same thing you see. Here what they have given, two particles of equal masses go around a circle of radius are under the action of their mutual gravitational attraction. What is speed they are saying? Again, here in this case, we have only two particles, guys. How many particles do we have? Two particles. So obviously, they will be moving under the effect of what? So we have two particles. Let us say m mass and m mass. They are going around the circle. So what we can take? They will be moving under the effect of gravitational force only. So what is the force acting? Gravitational force. Let us say is performing circular motion in clockwise sense. How will you find speed at any point? Along the sense of rotation at the given point. We are just going to draw a tangent. So what is the net force now between two masses? As you all know, here if you can write the net force. So what will net force value be? It will be G M M divided by what is the distance between them? 2r whole square, guys. So it will be Gm square divided by 4r square. So this net force will provide us the necessary centripetal force. Implies I can write m into v square. It is performing circular motion in a circle of radius r, should be equal to gm square divided by 4r square. So I can cancel out m and square, r and square. So what will be left out with? Implies you will get v square value as, implies we'll get v square value as gm divided by 4r. So I'll get v value as 1 by 2 into root over gm divided by r. I hope it is clear, all of you. Yes or no? So whenever object is performing circular motion, right, it will do so. How is it going to do so? With a certain force directed towards the center of the earth called as gravitational force, guys. Sorry, centripetal force. And who will provide the centripetal force? The resultant of gravitational force of attraction between these two masses will provide the necessary centripetal force. Clear, all of you? I hope it is clear, everyone. Let's see the next question. Consider a planet in solar system which has a mass equal to that of the earth and average density twice that of the earth. If an object weighs w on the earth, its weight on the planet. So what is acceleration? What is weight on the earth again? Weight on earth is taken as, mass is not going to change, gravity on earth. So how we can write gravity in terms of density is given and radius is given, guys. So what we can write? 4 by 3 pi g rho of earth into radius of earth. Okay. What will be weight on the planet now? It will be mass into g on planet. What we can write? M into 4 by 3 pi g rho of planet, r of planet, guys. So what they have given, which has mass equal to that of the earth, average density is given twice that of the earth. Okay. So in terms of mass and density they have given. Okay. Mass is same they have given and density they have given. So we need to find the relation between radius, guys. So what we can consider, we know density is given as mass by volume or not. Yes or no, all of you? So what we can write here? Mass is same. So density is inversely proportional to volume, we can say. So density will be inversely proportional to r cube I am going to get. So what is rho 1 divided by rho 2 now? It will be r2 divided by r1 whole cube. Yes or no, all of you? So what will be r1 divided by r2, beta? I can write it as rho 2 divided by rho 1 whole power 1 by 3. So they are asking us to find weight on the planet. So weight on the planet divided by weight on the earth if I do. Right, what will happen if we are dividing these two, guys? What will happen now? Small m gone. 4 by 3 pi, 4 by 3 pi gone. G gone, G gone. So what will I get here? Planet to earth I am taking. So it will be density of planet, radius of planet divided by density of earth, radius of earth. Masses they have said are equal, guys. So what I can write now, radius of density of planet to density of Earth. How can I write radius of planet to radius of Earth? I can write it as density of Earth to density of planet. Whole power, how much are we getting? 1 by 3, guys. Clear, all of you? So what will this turn out to be? If I just take it, I'll get it as density of planet divided by density of Earth, whole power 2 by 3 will get. So what is the weight on the planet they're asking? So weight on the planet will be, what is density on the planet, guys? It is given as 2 times the density of Earth divided by density of Earth, whole power 2 by 3. So I'll get it as 2 power 2 by 3, right? So what will be the weight on the planet? It will be 2 power 2 by 3 times the weight on the Earth, which is 2 power 2 by 3 times of W. I hope it is clear. Masses are same, densities relations are given, but nothing has been mentioned regarding radius, guys. So what we have done, by using density is mass by volume, we have calculated a relation between radius and densities, then substituted radius in terms of densities here. Understood, everyone? I hope it is clear. Next question, let us see. If acceleration due to gravity on the surface of the Earth is g, the speed with which a body hit by the Earth's surface when released from a height equal to radius of the Earth. The speed with which a body hits the Earth's surface when released from a height equal to radius of the Earth, they are saying. Again, whenever such type of motions are there, guys, we are just going to conserve mechanical energy of the system. So from where is it released? It is released here, somewhere from here. This is the center you can take, right? So it is released from what height? So already this is equal to r. It is released from a height h is equal to again r only. So you can consider it has some mass m. So it is released, u is equal to 0. So what will happen? Will it be falling under the effect of gravity or not? Yes, it is going to fall under the effect of gravity. Gravitational force is only present, which is conservative force. So when only conservative forces are there, what we can conserve? We can conserve mechanical energy of the system, guys. So what is going to happen? Whatever is the initial energy, we can write it as equal to final energy. Initial kinetic plus initial potential will be final kinetic plus final potential. So what is initial kinetic energy? Because it is released, it will be 0. It is at a distance h above the surface of the Earth. Just now we have seen it is given as minus g capital M small m divided by r plus h. H value is anyhow r. Final kinetic energy, I don't know, let us say it is hitting with speed v, half mv square plus what is final potential energy on the surface of the Earth? What is it? Minus g capital M small m divided by r. Yes or no, everyone? So what are we going to get? Minus g capital M small m divided by 2r. This I'll send on the other side. So I'll get plus g capital M small m divided by r will be equal to half mv square. So I'll get g capital M small m divided by 2r will be equal to half mv square. From this again we can calculate, we can cancel out m, 2 and 2. What will you get v square value as? I'll get it as gm divided by capital R. Implies I can write v value as root over gm by capital R. So if I say we are multiplying and dividing by r, so I can write this as root over g into capital R, guys. Clear, all of you? So whenever object is released from a certain height h equal to r from the surface of the Earth, then what is going to happen? It will be hitting the ground with what speed, beta? Let us imagine it is hitting the ground with speed v. That speed happens to be root over gr. Clear, all of you? At a certain height h above the surface of the Earth, potential energy will be minus g capital M small m divided by r plus h, right? And on the surface of the Earth, it will be minus g capital M small m divided by capital R. Clear, all of you? Yes or no? Let us talk about next question. Three particles of mass 2m, small m and 3m are placed at points A, B and C respectively. BC is given as 3 by 2 times of AB. Okay, m is very small than 2m and at time t is equal to 0, they are all at rest. At subsequent times before any collision takes place, what is going to happen? Right? They are talking about motion of small m, guys. So what we can do? What is this distance given? If I say this distance is r, what will this distance be? Will it be 3r by 2 or not? Let us imagine this is first mass. Let us imagine this is second mass. Now what will happen to small m? Second mass will attract it F2. First mass will also attract it F1. If I talk about F1 force, what is F1 force beta? G into 2 capital M small m divided by r square. So I'll get it as 2g capital M small m divided by r square. What is F2 value? G into 3 capital M small m divided by what is the distance here? 3r by 2 whole square beta. So I'm going to get this as 9 by 4 you will get, or you can write it as 4g capital M small m divided by r square by 3r square. Is this clear? Now which force is greater, you see? Which force is greater? So as you can see, three particles of masses 2m, small m and 3m are placed at points A, B, C respectively, with BC is equal to 3 by 2 AB. M is very small than 2m and at T is equal to 0. They are all at rest. At subsequent times before any collision takes place, what is going to happen? They are asking. So what will happen in this situation? Initially, I'm saying, guys, I'm not saying at any time. Initially, if I consider F1 value is more than F2 value. Yes or no? F2 value will get it as 4 by 3 G capital M small m by r square is 1.33. Here you have 2 times. So initially, if I say initially F1 value is more than F2, it means is there some net force acting on small m or not? There is some net force acting on small m. This is the net force. So in that case, will it accelerate towards 2m, guys? Yes or no? So first m will move towards 2m mass. It will move towards 2m mass. Now as it is moving towards 2m mass, is smaller value decreasing or not? Yes. If smaller value is decreasing, what will happen to force value? It will continue to increase again. What will happen to this force value? It will continue to decrease again. Yes or no, guys? Initially, I'm saying initially F1 is greater than F2. So initially I can say small m moves towards 2m initially. As it is moving towards 2m, what will happen to smaller value? Decreases. Means the force due to 2m will try to increase. What will happen to 3r by 2 value? It increases. Force due to 3m will decrease, guys. So what is going to happen? It will continue to move in this manner only. So m will be moving towards 2m before it collides with 2m, guys. As small m moves towards 2m, force of attraction due to 2m will increase. Force of attraction due to 3m will decrease. So it means what is going to happen? It will further move towards 2m only. Understood, all of you? Initially, F1 is greater than F2. At any instant, F1 will be going on increasing. F2 will be going on decreasing. So net force will totally be towards 2m mass only. So small m will be moving towards 2m mass, guys. Clear, all of you? Gravitational force between two masses varies as F is inversely proportional to r cube. Orbital speed of the satellite varies with the radius as what they are saying. Whenever object is performing circular motion, satellite motion in circular path, you will say. What we should have? Centripetal force. Who will provide it? Gravitational force. How will you write centripetal force? mv square divided by r. What is gravitational force here? It is inversely proportional to r cube. So can I write it as k divided by r cube or not? So what we can cancel out here? R and cube. What will be left out? Square will be left out. From this I can say v square is inversely proportional to r square. So v will be inversely proportional to r. Direct case, guys. Understood, all of you? Gravitational force is going to provide necessary centripetal force here. And centripetal force can be given as mv square divided by r. Understood? Direct case again. A uniform spherical shell gradually expands, maintaining shape. Radius is increasing. They are saying what will happen to gravitational at the center. Potential, if you see, potential at the center, it will be potential inside because center is lying inside. Everywhere inside the shell, potential is constant. How much is it? Minus gm divided by capital R. Now what they are saying, mass is constant, shell is expanding. So as radius increases, R value is increasing. What will happen to potential inside? Dekho, please try to understand. R value is increasing. Means potential value will become less negative or not? Less negative means what is the situation? It will become more, guys. The potential will increase. Most of them will write potential decreases. Will be wrong, guys. Right? In this situation, as R value increases, potential value will become less negative. Initially, it is more negative. Now it is less negative. It means potential inside will increase, guys. Clear, all of you? Yes or no? I hope it is clear. Because if you see, escape velocity from a spherical planet is about v naught. Escape velocity from a planet having the radius twice the radius and half the density. What is escape speed from the surface of a planet, guys? It is given as 2 into g at surface, or if I write in terms of, okay, let us write it in terms of g at surface into r. How can I write g value? Right, it is 4 by 3 pi g rho r or not. So I got it as 8 by 3 pi g rho r. R into r will be r square again. So what we can say, escape speed will be proportional to root rho and r, guys. So what we can write, v1 divided by v2 will be root over rho 1 by rho 2 into r1 divided by r2. They're asking v2 value, it will be given as root over rho 2 by rho 1 into r2 by r1 into v1. What is density? Half the density they have given. So what is the rho 2 value? It is rho 1 by 2 into rho 1. What is r2 value? Twice the radius, 2r divided by r1 into v1. So I'll get this as 1 by root 2. Here I'll get it as 2 into v1. So answer should be root 2 times of v naught, guys. Clear, all of you? What is escape speed given in terms of density and radius? It is given as root over 8 by 3 pi g rho into r square. Understood, all of you? Yes or no? I hope it is clear. Next question, you see, force between a hollow sphere and point mass m inside the shell. Inside the shell, is there any mass? No mass. No mass means no attraction. So what will it be? It will be 0 everywhere inside the shell, guys. Correct variation of value of acceleration to gravity with depth as one moves towards the center, it seems. With depth, they are saying, guys. What will it be? From surface, we are moving to a certain depth again. Right. So what will be the variation? So here, you see, with the depth, they are saying. Here, depth value is how much? 0. Here, depth value is r. Here, depth value is r means, will this be small r is equal to 0 or not? So it will follow second graph, guys. If you, we are already aware of the plot, no? G versus small r, we know. Which graph it is following? First straight line, then it is going to follow a square hyperbola. Yes or no? This is G value at surface. Okay, here small r value is 0, here small r value is capital R, here G capital M divided by R square. Small r value is 0 means depth will be how much? This is at center. At center, what will be the depth? Radius of earth, guys. Small r is equal to capital R. At surface, what will be the depth? 0. So now we are moving from surface to center. Means d is equal to 0 to d is equal to r. So what will happen, beta? G value with depth they are asking. So when depth is 0, what is G value? Maximum or not? And when depth became equal to r, what is G value? It is going to be equal to 0 again. Clear, all of you? It is going to follow a straight line with negative slope, guys, and positive intercept. Understood, everyone? R is equal to 0 is center. Center means what will be depth? R. R is equal to capital R is surface. Surface means what will be depth? 0. So as you move from surface towards the center, G value will be decreasing, guys. Linearly, it will be decreasing. That is what we have taken. Clear, all of you? And at center, it becomes 0. That is the reason I've taken something like this. I hope you understood the question. It's a very good question again, guys. Next. If kinetic energy of satellite moving around the planet is doubled, then what is going to happen? They are asking. Kinetic energy is doubled. Basically, what is kinetic energy given as? Half mv square. So for kinetic energy, what is k dash value? It is 2k. So how much is this? Half mv dash square will be 2 times of half mv square. We can cancel out half m and half m. So what will I get v dash square value as? I'll get it as 2 into v square. So what is v dash? It is root 2 times of v or not? So here, what is v? Satellite it is. So v will be nothing but orbital speed. Yes or no? So what will v dash value become? Root 2 times of orbital speed. What is root 2 times of orbital speed? It is escape speed. So when kinetic energy is doubled, it means speed becomes root 2 times the orbital speed, which happens to be escape speed. Whenever you are giving escape speed to a satellite, what will happen, guys? Will it escape from the gravitational pull of the earth or not? Will escape from the gravitational pull of the earth. Understood, everyone? So or no? Did you see? Body is projected vertically upwards from the surface of a planet with a speed equal to half the escape speed. The maximum height, again, such type of questions are very good, guys. Here speed is less than the escape speed. So will it go to interstellar space? No. From where it is? From the surface, it is projected with a certain speed. How much is that speed? It is equal to half of the escape speed. Let us imagine mass is small m. Right? What is going to happen? The object will be moving in the direction of velocity with decreasing speed. Maximum height they are saying. So at this point, v value will become 0. So it has risen a height h, guys. So during the entire motion from the surface to a certain height h, will it be moving only under the effect of gravitational force or not? Which is varying again. It is a conservative force, guys. So whenever only conservative forces are acting, what we can do? We can conserve mechanical energy of the system. So initial energy will be equal to final energy. Initial kinetic plus initial potential should be final kinetic plus final potential. Finally, what is your kinetic energy? 0. Initially, what is potential kinetic energy? Half m VE divided by 2 whole square. What is initial potential energy? Initially, it is on the surface, guys. So I'll write minus G capital M small m divided by R. Finally, minus G capital M small m divided by how much beta? It is at a certain height h above the surface. It is h. Now, please tell me, what will I get this as? I will get it as 1 by 8 m into VE square minus G capital M small m divided by R should be minus G capital M small m divided by R plus H. What is VE from the surface of the earth? It is root over 2 gm by R. So if I write VE square, what will it be, beta? I'll get it as 2G capital M small m, 2G capital M divided by capital R. Will you get or not? Minus G capital M small m divided by R should be minus G capital M small m divided by R plus H. So what we can cancel out? M, M, small m, capital M, capital M, capital M, G, G, G. What will I get here? 2 ones, 2 fours I'll get. So we got 1 by 4R minus 1 by R will be equal to 1 by R plus H minus 1 by R plus H. Yes or no? So what is this you are going to get? If I take 4 as the LCM, you will get it as implies minus 3 divided by 4R will be equal to minus 1 divided by R plus H. Minus and minus you can anyhow cancel it out, guys. So what are we going to get? I will get 3R plus 3H will be equal to 4R. So 3H value you will get it as R. So H value will be R divided by 3. Clear, all of you? Understood or not? So to what maximum height it will be moving? It will be moving to a height r by 3, guys. Is that clear? Whenever such type of questions are asked, basically apply conservation of mechanical energy blindly. There is nothing to do else, guys. But don't take this as zero again. Most of you will take potential energy here as zero. On the surface of the earth, potential energy is minus g capital M small m divided by capital R. At a certain height, minus g capital M small m divided by R plus H. As simple as that. Clear, everyone? Yes or no? Now, what they are saying here in the next question, a uniform rod of mass m and length L is bent to form a semicircle. So what will length become, beta? Semicircle means length will become circumference, which is pi r. So what will be radius here? It will be L divided by pi. Now it is bent to form a semicircle. Something like this. They're asking us to calculate what is the gravitational potential at the center. Potential is a scalar quantity, guys. Right? So if I want to calculate, what will I do? Is a continuous mass distribution. So I'll take a small element here. Right? This small element I am going to take. Right? The small element we will be taking. At how much distance? The small element on the circle. Can I consider it to be just a point or not, guys? Yes. And how much is the distance of this element? It will be at a distance small r. Or you can say it will be at a distance capital R, which is the radius. So because of this element, because it is a small point mass only, what will be potential, beta? Small potential, if I say it is minus g into dm divided by r. Now you take any element on the ring, guys. Will all the elements, will they be at the same distance from the center or not? Or will the center be at same distance from all the elements? Yes. Will g value change? No. Will r value change? Distance of the given point from the element for different elements, is it changing? No. Will dm value change? No. So if I want to find potential, what I'll do? I'll simply apply integration. Integral of minus g dm divided by r you are going to get, right? Minus g divided by r integral dm. Sum of all the elements you will get it as, it will be equal to radius. And how much is radius, beta? L by pi. So I'll get the answer as minus pi gm divided by L. Clear, everyone? Understood, all of you? A uniform rod is converted into a semicircle. Means length will become equal to circumference. So what will radius become from that? It will become L divided by pi. Okay. So when it became L divided by pi, so what we can tell regarding, so because it is continuous mass distribution, first we will take an element and find out what is potential. So what will be potential due to this element? Minus gm by r, guys. Right? And you take any element, the center will be equidistant from all the elements, guys. So what will be the potential? It will be minus gm divided by capital R. Here R value is L by pi. We will get it as minus pi gm divided by L. Clear, all of you? Yes or no? Hope it is clear. Body of mass 500 grams is thrown upwards with a velocity 20 meter per second and reaches back to the surface of the planet in 20 seconds, it seems. Then what is the weight of body on the planet, they are saying? Reaches back to the surface. So are they asking weight of the body on the planet? Okay. A body of mass 500 grams is thrown upwards with a velocity 20 meter per second and reaches back to the surface. Acha. So let us say, can I find out g on planet on this or not, guys? So what is time of flight? We know if it is projected with some speed u, it is 2u divided by g or not. So what I can write g value as 2u divided by t. So 2 into, with what speed we are projecting? 20. After how much time? So what is the value of g on planet? Is 2 meter per second square. So what will be the weight on the planet, beta? It will be, mass will be anyhow same. Into g on planet you can write, which will be, mass is half kg into 2. You will get it as 1 Newton, beta. Whenever object is projected vertically upwards, right? After what time will it hit the ground? 2u by g. So from time is given to us, speed is given. So we will find out g on planet. What will be weight on planet? It will be mass on planet into g on planet. Mass will be same everywhere, guys. Okay. Clear, all of you? Next question you see. A satellite moving around the Earth, a satellite moving around the Earth in a circular orbit of radius r with speed v. It suddenly loses some of its energy. What is going to happen? So basically, what is the total energy, beta? Total energy in satellite is minus g capital M small m divided by r. If it is losing some of its energy, so what will it become? So it may lose some kinetic energy or it may lose some potential energy. What is kinetic energy given? Basically, I can write half mv square. Yes or no? So if it is losing some energy means, let us say v is decreasing. It means kinetic energy is decreasing or not? Minus g. What is total energy, beta? It is minus of kinetic energy. Obviously, opposite of it. So what is happening to E value? Some of its energy it is losing means E value is decreasing. It means what should happen to kinetic energy value? It should increase or not? Now, kinetic energy is increasing. So if kinetic energy is increasing, mass will not change. What will happen to speed? Speed will increase. E value is decreasing means will it become more negative or not, guys? When will it become more negative? If R value will be decreasing, guys. So E value is decreasing means it is becoming more negative. If it is becoming more negative, when will it become more negative? If R value decreases, guys. So what is happening to R here? R is decreasing. What is happening to V here? V is increasing. So R will decrease and V will increase should be the answer for this. Clear all of you?
So can't there be a condition in which, I mean, if the energy is decreasing, won't it be lost as heat instead of it increasing at the
What
time?
will be? What will be?
So if energy is decreasing, can't there be a case in which the energy is decreasing because of heat loss and not because of its kinetic energy increasing?
No, suddenly losses are coming means obviously sudden loss cannot be heat loss. Now, where will heat loss be there in vacuum, in space?
So how are we saying that the kinetic energy will increase?
Just by concept, we are saying E and K are negative of each other. So if E value became minus 2 joule, then K value will become 2 joule. Initially, E value is let us say minus 1. If there is decrease, it will become minus 2. So initially kinetic energy is 1. Now it became 2. So if E value is decreasing because it is minus of K, so obviously I'll say K value will increase. Negative, no, it is. Whatever is happening to E, opposite will happen to K. Understood?
Yes, understood.
Whatever is happening to E, opposite will happen to K because it is minus of E or E can be written as minus of K. The density of planet is 2 times that of the Earth. Acceleration to gravity at the surface of the planet is half that at the surface of the Earth. So what is given? Density of planet is 2 times the density of Earth. Acceleration to planet is half the acceleration due to gravity on the surface of the Earth. GE by 2 you can say. If radius of Earth is r, then what is the radius of planet they are saying? Very simple case again. So how will you write g value as? It is 4 by 3 pi g rho capital R. So I can write g on planet divided by g on Earth should be, because implies I can say g is directly proportional to rho into r beta. So I'll get rho of planet divided by rho of Earth, radius of planet divided by radius of Earth. What will you get Gp by Ge as? This term you will get it as 1 by 2. Rho p by rho e, what will you get? 2. Will be radius of planet, radius of Earth is given as r. Implies from this radius of planet, I can say it will be r divided by 4. Clear everyone? Direct question or not? In terms of density and radius, G value will be directly proportional to density and radius, guys. Is that clear? 3 particles, each of mass m, are placed at the corners of equilateral triangle of side A. The work done on this system in increasing the sides slowly from, it should be side D you take, guys. The work done on the system in increasing the sides of a triangle slowly from D to 2D. So just now we have seen that whenever 3 masses are placed on the vertex of equilateral triangle, what is the expression for potential energy? Minus 3 g m square divided by d initially. Finally, what is it going to happen? Minus 3g m square divided by what is the separation now? It became 2d. So what is the work done? We are doing work against gravity here, beta. Which will be change in potential energy, final minus initial. So final value is minus 3g m square divided by 2d minus of minus 3g m square divided by d, which I'll get it as 3g m square divided by d minus 3g m square divided by 2d, which I'll get it as 3g m square divided by 2d. This is the work done in increasing the side from some d to 2d, guys. Clear, all of you? So initially they were at a distance a apart. Now I want to increase the separation between them. So if I am increasing separation means I am doing work against the attraction, guys. So when work is done against the gravitational force, it means work is done by external agent, guys. Understood, all of you? Clear, everyone? What is escape speed of a body from the surface of the planet? It seems escape speed is given as 2 into g into mass of the planet divided by radius of the planet. So it is depending on what, beta? Mass of planet and angular. Will it depend on angle of projection? It will depend on mass of planet, but will it depend on angle of projection? No. It will depend on mass on planet. Will it depend on mass of body? No. Will it depend on energy? Is it depending on mass of body? No. It is depending on angle of projection? No. So escape energy of a body from the surface of a planet, it will be independent of mass of the body and angle of projection. Is it going to depend on angle of projection only? It seems, guys. No. So third one will be correct. It will be independent of mass of the body as well as the angle of projection. If Earth stops rotating about its own axis, then at equator, what is going to happen? They are saying, right? Spring balance will depend on, if you talk about oscillation chapter we study, guys, time period of a spring block system. If I take, it will be given as 2 pi root over m divided by k, mass and spring constant. Whereas if I take time period of a simple pendulum, which is a physical balance, guys, right? Time period of simple pendulum, if I say, what will happen? It will be 2 pi root over L divided by g beta. So for spring block system, if I consider, it is independent of g. What is it? It is independent of g. Whereas simple pendulum, if I take, or physical balance, if I take, it is dependent on g, guys. So what are they asking? If Earth stops rotating about its own axis, omega value becomes 0. Then at equator, we know at equator, what is g value given? G at equator will be g at surface minus r omega square cos, at equator anyhow it is cos 0 only. So if omega becomes 0, implies what will g at equator become? Will it be g at surface? Initially it was g at surface minus r omega square. Now it became g at surface. So what has happened to g at equator? It has got increased or not? Yes. So here g value will increase, overall value will decrease. So time period of simple pendulum will decrease. However, for spring block system, there will not be any change, guys. Okay. So time period of spring balance will increase. No change in this, guys. Because for spring block system, it will be independent of G. Reading of physical balance will decrease. Yes, it is going to be correct. Why? Because G value is increasing. G value at equator increases when angular speed of the earth becomes 0 and it becomes maximum, guys. Clear, all of you? I hope it is clear. For a satellite to be geostationary, one of the necessary condition, it should revolve in which sense, beta? It should revolve from in an equatorial plane from where to where? West to east. So basically, if we take, I'll just show you. If this is the earth, guys, imagine this to be the earth. Earth rotates about in its own axis in this sense. So if I observe from the top, how is the sense? Anti-clockwise, guys. If you are at pole and you are observing, you are standing here and you are observing it. You have earth below. So I'll observe that Earth will be rotating in which sense? Anti-clockwise sense. From where to where? From west to east. This is our north and this is our south. Now, geostationary satellite, where will it revolve? It will revolve in equatorial plane again, in this plane. It should rotate with same angular speed as that of the Earth, guys. So it should also rotate, if you are observing from top, it should rotate in anti-clockwise sense in equatorial plane from west to east, guys. Clear all of you? The third one will be correct case. Clear all of you, everyone? That is the basic logic. Angular speed of the geostationary satellite will be equal to angular speed of the Earth with respect to the center of the Earth. Okay. Understood, everyone? I hope you have. Next question, you see. A mass small m is placed at a point on the axis of thin circular ring of mass m and radius r. If the mass is moved further away such that OP becomes twice the initial value, what is going to happen to the force of gravitation? By what factor will gravitational force decrease? They're asking. So what will be initial field beta? If I take only magnitude, G capital M small m into x. What is x value here? R divided by under root of r square plus r square, which I'll get G capital M GMX only it is. What is field due to a ring? It is GMX divided by r square plus x square whole power 3 by 2, guys. Okay. So what is the value of field here? If I consider initially, what is the field? It is GM. What is x value? R divided by r square plus r square whole power. What will I get? 3 by 2. So what will this turn out to be? GMR. Here we have 2r square. 2r square means you will become 2 power 3 by 2 will be 2 root 2, guys. 2 root 2 r cube you will get. So this is GM divided by 2 root 2 r square. Now implies what is the force? We know force value will be mass times of field, guys. So how much is the force initially? G capital M small m divided by 2 root 2 r square. Okay. The same manner. What is the field here if I consider? Finally, what has happened finally? The point, the distance became twice the initial value. Means it became 2r, guys. So what will I get? Gm into 2r divided by r square plus, this is 2r whole square now. Whole power what here? 3 by 2. So which I'll get it as 2gmr. In denominator you will get r square plus 4r, 5r square you will get. 5r square whole power 3 by 2 will be 5 root 5 r cube. So what is the final field? 2gm divided by 5 root 5 r square. Implies what will be the final force acting beta? It will be mass into final field, which turns out to be 2g capital M small m divided by 5 root 5 r square. By what factor it is increasing, they are saying. So what I can write final value as, can I write it as 2 by 5 root 5? If you look at this term, G capital M small m divided by r square. This G capital M small m divided by r square beta, can I write it as 2 root 2 times of f initial or not? Yes. So what will happen to f final now? Root 2 and root 2 will anyhow, this is 5 root 5, sorry. So what will happen? It will become 4 root 2 divided by 5 root 5 times the initial force. Clear, everyone? 4 root 2, it becomes 4 root 2 divided by 5 root 5 times. Understood, all of you? Final force will become this much. They are saying by what factor the force of gravitation will decrease. Means it should be 5 root 5 divided by 4 root 2, no? Then, if that is the case. Okay, I cannot say it is decreasing. I will simply say it is going to get converted to 4 root 2 divided by 5 root 5 times the initial force, guys. Clear, all of you? It is going to become 4 root 2 divided by 5 root 5 times. Directly field will be given as gmx divided by r square plus x square whole power 3 by 2. Angular momentum of an orbiting body depends on angular momentum. If I consider what is angular momentum here, if I take only orbital angular momentum, it is basically given as mvr. Is it depending on mass on the mass of the orbiting body? Yes. Is it depending on radius? Yes. So depends on mass, it depends on radius, right? In the same manner, radius of orbit only they are saying. Now please tell me what is v value? How can I write v? Is it root over, it is, if it is orbiting, then I can write orbital speed as root over 2g, root over g capital M divided by small r. Yes or no? So what will I get L value as beta? I'll get it as small m into root over g capital M into root r, you can write. So it is depending not only on mass of the orbiting body, it will depend on mass of the central body as well as radius of the orbit. So fourth one will be correct, guys. Clear, everyone? Basically, in case of satellite motion or planetary motion, we will neglect the spin angular momentum of the planet or satellite. The only orbital momentum which we consider will be orbital angular momentum. How much will that orbital angular momentum be? It will be m into v into r. So because it is orbiting with orbital speed, so I can write v value as root over g capital M by small r. So it will depend not only on the mass of the orbiting body, it will depend on mass of the central body as well as the radius of the orbit, guys. Clear, everyone? Yes or no? I hope it is clear to all of you. Next question you see. If r is the radius of Earth and g is the acceleration due to gravity, then what is mass of the Earth? It seems very direct question. Directly you can write it. It is g capital M divided by r square. So mass can be written as small g into r square divided by capital G, guys. The escape velocity on the Earth is 11.2 km per second. Its value for a planet having double the radius and 8 times the mass. So we know what is escape speed given as root over, from the surface means it is given as root over 2gm by r. So what is escape speed is directly proportional to root over m by r, guys. So what has happened to mass? It became 8 times. What has happened to radius? It got doubled. So overall, will it become doubled or not, guys? So I can write v1 divided by v2 will be root over m1 divided by m2 into root over r2 divided by r1. So what has happened to mass beta? It became 8 times again. What has happened to radius? It became 2 times. So what will this become? It will be root over 2 by 8, which I can take it as root over 1 by 4, will be 1 by 2. So what will be v2 value? It will be 2 times of v1. Okay, which is 2 times of 11.2 kilometer per second. It is 22.4 kilometer per second. Clear, everyone? Understood, all of you? I hope it is clear. Any doubt in that? Definitely you will get questions based on this model which we are going to discuss now. If geostationary satellite is orbiting around the Earth at a distance 6r above the surface, means how much distance from the center? 7r. Time period of another satellite of a height 2.5 from the surface. So what is radius, orbital radius for first case beta? It is 6r plus r, which will be 7r. What will be orbital radius of second case? It is 2.5r plus r, which is 3.5r. And I said already, the square of time period will be proportional to cube of the radius, guys. So what we can write here, or I can say time period is proportional to r power 3 by 2. So I can write t1 by t2 will be r1 divided by r2 whole power 3 by 2, which will be 7r divided by 3.5r whole power 3 by 2, which we can write it as 2 times of 3 by 2. 2 times of 3 by 2 is nothing but 2 power 3 by 2 is nothing but 2 root 2, guys. So what will I get T2 value as? I'll get it as T1 divided by 2 root 2. What is T1? It is time period of geostationary satellite, which happens to be 24 hours. This is a previous year question, guys. It is 12 divided by root 2. You will get it as 6 root 2 hours. Clear? Very important concept. Time period, square of time period will be proportional to cube of the radius. So time period can be written as proportional to r power 3 by 2. Understood all of you? I hope you have. Let us see next case. If radius of the earth shrinks by 1%, mass is remaining same. What is happening to acceleration to gravity, they are saying. So we know g value is given as gm by r square. Mass is constant, g is constant. So can I write g is inversely proportional to r square beta? Yes or no? So g will become directly proportional to r power minus 1 by 2. One quantity is expressed in terms of another quantity raised to some power. So what will I get here? I can take relative error. Delta g by g will be minus 2 times of delta r divided by r. So delta g by g into 100 will be minus 2 times of delta r by r into 100. So what is delta g by g into 100 now? It will be minus 2 times. So what is delta r by r into 100? It is shrinking, means reducing. So minus of 1% you will write. So I'll get it as plus 2%. What is plus indicating? Plus indicates that there will be increase in the acceleration to gravity by how much beta? By 2%. So whenever radius is shrinking by 1%, g value will increase by 2%, guys. Clear everyone? 2 point masses capital M and small m are placed at a distance r. The gravitational potential at a point where field intensity is 0, they are saying. Again, very good question. So we have two masses here. One is capital M mass, other is small m mass. They are separated by a distance r, let us say. Right? They're separated by distance r. They're asking at point where field is 0, what is potential? Where will field be 0? Will it be at neutral point or not? So if I assume the neutral point is at a distance x from m, at what distance will it be from small m? R minus x. So how can you find x value beta? It will be r divided by root over, this is m1, this is m2. I'll write small m divided by capital M plus 1. Yes or no? So what will be r minus x now? If you do r minus x, I'll get r minus of r divided by root over small m by capital M plus 1. If I solve for this, guys, you will get it as r minus x value, you will get it as r divided by root over capital M by small m plus 1 I will get, guys. They're asking potential at point P. Always remember, potential at any point will be due to algebraic sum of potential due to all the masses present in the system. So potential at point B, how many masses we have here? Let us take, we have two masses. So we will take potential due to first mass as well as potential due to second mass. Now, point masses again. So what is potential due to first mass, guys? I can write minus g capital M divided by x. What is potential due to second mass? Minus g small m divided by r minus x. Yes or no, everyone? So what will this become? I can write it as, if you solve for this, you will get minus g capital M here divided by r, and in, I'll just take it to the left hand side little bit. So I'll get it as minus gm divided by r. Here I'll get root over small m by capital M plus 1. This will be minus g small m divided by r. Here I'll get root over capital M by small m plus 1. So what will this turn out to be? I can write it as, if you are just writing it, this will be minus gm divided by small r. Here I'll get minus g small m divided by r. From this term, root m, and what will you get? Minus g by r root over small m capital M you will get. And from here also I'll get, from here also I'm going to get minus g by r. M by root m will be root small m again. So I can write root small m into capital M. So what will this turn out to be? If I take my, this can be written as minus g capital M by r minus g small m by r minus 2g by r root over small m capital M. So if I take minus g by r common, you will get capital M plus small m plus 2 root of small m capital M, guys. This will be the potential at a point where field will be 0. Minus g by r capital M plus small m plus 2 root capital M small m. Understood all of you? Where will field be 0? At neutral point. How will you find neutral point? If we have two masses, m1 and m2, from m1 mass, it will be r divided by m2 by m1 plus 1. From m2 mass, it will be r divided by m1 by m2 plus 1, guys. Root over m1 by m2 plus 1. Next question, if you see, they are asking us variation of acceleration due to gravity as one moves away from the center. So from center, if you are moving, first it will follow straight line, then it is going to follow inversely proportional to r square, as you all know. Okay, we have done this just now. If the sun and planets carry huge amounts of opposite charges, then which is incorrect corresponding to Kepler's laws of planetary motion? Sun and planets are carrying opposite charges. Means, will there be attraction only or not? Yes, so that attraction will provide necessary centripetal force. So along with gravitational force, you will also have electrostatic force of attraction here. So in this situation, what will not change? Everything will be same only, guys. Huh? All three Kepler's laws would be still valid. Okay, because they are carrying opposite charges here. So opposite charges means there will be attraction only. So apart from gravitational force of attraction, you are going to have electrostatic force of attraction also. So overall, you will have only conservative forces, and torque also will be 0. So you can say that all will be correct, guys. Two particles of mass m1 and m2 move in circular path under the action of gravitational force, then m1 is greater than m2, it seems. Whatever it is the situation, guys, what will be the net force acting here? Net force acting on any mass you take, it will be g m1 m2. Let us say diameter is d. In circular path they are saying, so I'll get d square. So what will be the centripetal force here, beta? Centripetal force will be provided by the net force. So what I can write if I say first mass? So gm1 divided by, see, here their centripetal accelerations will be different, guys. Okay, so two particles of masses m1 and m2 move in circular path under the action of mutual gravitational attraction. Acha. So I cannot say they are going to move in which circle also they have not mentioned, no. So always remember in such cases, guys, here you have m1, here you have m2. Okay, now you see m1 is greater, it seems. So if m1 is greater, obviously where will center of mass lie? Center of mass will be lying here. It will be near to m1 mass, guys. You can say it is at a distance r1 and here it is at a distance r2. So always remember, right, here in this case the masses will be performing circular motion with center of mass as their center of the circle, guys. So m1 will perform circular motion in a circle of radius r1 and m2 will perform circular motion in a circle of radius r2, guys. So they are going to perform circular motion with center of mass as their center. So here uh, R1 value will be less than R2, because why is this situation? Here M1 is greater than M2 or not? So obviously center of mass will be located at a point where there is more mass. So where will they be located? R1 value will be less than R2. They will be performing circular motion about the center of mass with center of mass as their center, guys. So I can say radius of circle M1 will be less than radius of circle M2. They move in same circle? No. If they have same masses, they will move in same circle, guys. Radius of M1 is more than that of M2? No. Radius of circle M2 is more than that of M1? Yes. They cannot move in circular path is wrong. They can move in circular path, guys. But that circle will be centered at their center of mass. Clear, all of you? It's a very important question. They're saying escape velocity of a body on on an imaginary planet which has half the radius of the Earth and double the average density. Again, just now we have seen that what is escape speed given as? It is given as root over 8 by 3 pi g rho into r square. So what is escape speed, beta? It is directly proportional to root rho into r. So I can write v2 divided by v1 as rho 2 divided by rho 1 into r2 divided by r1. Half the radius they are saying. So this term will become how much? This term will become 1 by 2. Density is given as double again. So this term totally will become root 2, guys. Root 2 by 2 will be anyhow 1 by root 2. So overall I'll get this as 1 by root 2. So our V2 value will be V1 divided by root 2, which is escape speed from the surface of the earth divided by root 2, guys. Direct question, very important logic again. 8 by 3 pi 0 r square will be the escape speed. Clear everyone? Yes or no? Next, the radius of the earth is r and acceleration to gravity on the surface of the earth is small g. The potential at the center of earth. Please see, earth is considered as a solid sphere, guys. So what is potential inside the solid sphere? It is minus gm divided by 2 capital R cube 3 capital R square minus small r square. At center, what is small r value? Small r value is 0. What will be potential at center, beta? It will be minus 3 by 2 gm by r. Yes or no? Or if I multiply and divide by r, are we making any change? No. So I can write it as minus 3 by 2 g into small r. Clear everyone? Understood everyone? Please remember this, it's a very important formula. Potential inside everywhere will be given as minus gm by 2 r cube inside a solid sphere again. Minus gm by 2 r cube into 3 capital R square minus small r square, guys. Clear everyone? Yes or no? I hope it is clear. Next case you see, a uniform solid sphere of mass m and radius a is surrounded symmetrically by a uniform thin spherical shell of equal mass m and radius 2a. The gravitational potential at the center at a distance 3a by 2 from the center. So one they have given what, beta? One they have given solid sphere. And what is the other that they have given? The other that they have given is a spherical shell, guys. Yes or no? So as you can see in this situation, inside one is a solid sphere, beta. The whole mass will be distributed in its volume. A uniform solid sphere of mass capital M and radius a has been given. So from here to here, what is the radius? A. E is surrounded symmetrically by a uniform thin spherical shell of equal mass. And what is the radius? 2a. Both the mass are same. Here if it is m, this is also m. Where are they asking us to find? They're asking us to find potential at a point P. At how much distance is this point, beta? This point is at a distance 3a by 2. Means obviously it will be outside or not? Yes. So potential at any point will be potential due to all the masses present in the system. You can take first object as well as second object, guys. So what will it be? It will be potential due to first mass as well as potential due to second mass. Clear everyone? Now see, what is first mass? It is solid sphere. Where is the point? Outside the solid sphere. So what will you get here? Outside the solid sphere, what is the potential, beta? It will be minus gm. What is the distance from center? 3a by 2. Where is the given point P? It is inside the shell. Inside everywhere. Inside the shell everywhere potential will remain constant. Because mass is same, minus gm divided by its radius. How much is the radius here? 2a, guys. So I'll get it as minus 2 gm divided by 3a minus gm divided by 2a. So I'll get this answer as minus 7 gm divided by 6a, beta. This is potential at point P due to the given combination. Due to solid sphere, for the solid sphere, the point is outside, right? And for the spherical shell, the point is inside. Understood everyone? Yes or no? Always remember potential if you are trying to find out at any point, it will be algebraic sum of potential due to all the masses present in the system. Clear everyone? Just give me a second. I hope it is clear, all of you. Next question, let us see. Gravitational field is given by 10 I cap plus 10 J cap. Work done by an external agent to slowly shift a particle of mass 2 kg from point having coordinates 0, comma 0 to 5, comma 5. Work done by an external agent will always be what, beta? Work done by an external agent will always be equal to change in potential energy. And how I can write change in potential energy? I can write it as mass times of potential difference. Clear, all of you? There is a relation between field and potential. Basically, I can write field as minus of dV divided by dr r cap beta. So minus indicates gravitational field lines will always be in the direction of decreasing potential. I can also write dV value as minus of I bar dot dr bar. So differentiation is there. In order to remove differentiation, what should we apply? We are going to apply integration from some r initial to some r final. The potential will be v initial to v final. Integral dv, as you all know, you will get it as v. From where to where? V initial to v final. Should be equal to integral of I bar dot dr bar from r initial to r final. So I'll get V final minus V initial, which is potential difference. So how can I write potential difference? How can we obtain potential difference, beta? We can obtain potential difference by performing integration. So I'll do minus of from some R initial to some R final I bar dot dr bar. It's very important case again. Because field is varying with both x cap as well as x component and y component, guys. So I can write potential difference as minus of integral x initial to x final I of x dx plus integral iy dy from y initial to y final. Clear? So what is the work done now? It will be m into, how can I write potential difference? Right, so I'll write potential difference as minus of integral. I am moving it from 0, comma 0 to 5, comma 4. So initially it is at 0, x coordinate is 0, final x coordinate is 5. So what is x component of field here? 10. 10 dx I'll write. Yes or no? Plus integral of y coordinate is varying from 0 to 4. Y component is again 10 dy I'm going to write. And how much is the mass given? 2 kg mass is given, guys. So 2 into, what will I get here? Minus of 10 is anyhow constant. Integral dx will be x. From where to where? 0 to 5. Again 10 is constant. Integral dy will be y. From where to where? 0 to 4 here. So what are we going to get? 2 into minus of 10 5 is again 50 plus 40 you will get, which is 90. So what is the work done here, beta? Minus 180 joules will be the work done. Always remember, this is very important. Field will be minus of dv by dr r cap. We have studied this in electrostatics, guys. Field will be minus of dv by dr r cap. And from there, I can write potential as minus of I bar dot dr. If I want to find potential difference from one point to another point. If I want to find potential from infinity to 0. Clear, everyone? I hope it is clear. Let's see the next question. Relation between field and potential, very, very important, guys, again. A satellite is orbiting very close to the surface of Earth. A particle is to be projected from satellite to just escape from the field of the Earth. Escape speed from the Earth is VE, the speed of the particle with respect to satellite they are asking. Okay, so a particle is orbiting very close to the surface of the Earth. Sorry, satellite is. So what is the speed of the satellite, guys? If I talk about speed of the satellite with respect to the Earth, how much is it? It will be equal to orbital speed. Now what I have to do? A particle is to be projected from the satellite to just escape from the field of the Earth. So what should be the escape speed of the particle with respect from satellite we are projecting? So with respect to satellite, escape speed should be how much, beta? It should be VE. Yes or no? They are asking the speed of the particle with respect to satellite. Because I have to escape it from the satellite, right? It means I need to give uh, the particle escape speed with respect to satellite, guys. Okay. A satellite is orbiting very close to the surface of Earth. A particle is to be projected from the satellite to just escape from the field of the Earth. So what is this speed of the particle with respect to satellite? This should be escape speed with respect to satellite or not? This should be escape speed with respect to satellite, guys. So already if you see, satellite has orbital speed v naught. So it means, we'll just come back to this question. We have few more questions left. Quickly we'll complete, guys. I'll just tell you that question in some time. They are saying at what depth below the surface of the Earth, the value of G is same as that at a height h. 5 kilometers is given. Is it very small height or not, guys? So then I can apply G at a certain height will be G at surface into 1 minus 2h by r. And I can write G at a certain depth as G at surface into 1 minus d by r. So they are saying G at a certain height 5 kilometers is same as G at certain depth. So G at surface into 1 minus 2h by r will be equal to G at surface into 1 minus d by r. So what we can cancel out? Gs and Gs can be cancelled out. Right, so what are we going to get? I am going to obtain 1 minus 2h by r will be equal to 1 minus d by r. From this we can cancel out these two. So I'll get minus 2h by r will be equal to minus d by r. From this we can also again cancel out minus and minus, r and r. So at what depth are we going to get it, guys? Twice the height. So 2 times of 5 kilometers. So at a depth 10 kilometers, I can say acceleration due to gravity will have same value as that at a height 5 kilometers from the surface of the Earth. Clear, all of you? Yes or no? Next question, you see. 3 uniform spheres each have mass m and radius r are kept such that they are touching each other, guys. Okay, this is the situation. 3 identical spheres have been given. How are they? They are touching each other has been mentioned, guys. You can take it something in this manner. So something like this. So they're asking us to find out what would be the gravitational force on one sphere due to the other two. Right, now please tell me, let us imagine this is our first sphere, second sphere, third sphere. Are second and third spheres external to the first sphere? So whenever a point is external to the sphere, can I concentrate the whole mass at the center? I can concentrate it here. Same goes with second sphere as well as third sphere, guys. Now they are identical, so what we can say, the distance between them will be 2a. This is also 2a. This is also 2a. So now I have 3 masses which will be placed on the vertices of an equilateral triangle, guys. Yes or no? I have 3 masses which are now placed on the vertices of equilateral triangle. All are identical masses or not? Yes. So if I take, this is first sphere, this is your second sphere, this is your third sphere, right? What is the distance between them? 2a, 2a, 2a. What is the angle? 60 degrees. What will second sphere do to first sphere? Second sphere, what will it do? Is it going to attract or not? This is force due to second sphere. What will this do? It is also going to attract. So please tell me, what is the net force on first sphere? It is force on first sphere due to second sphere as well as force on first sphere due to third sphere. Now On one point, we have two vectors inclined to each other by an angle 60 degrees. What will be the resultant force beta? Under root of, I can write F12 square plus F13 square plus 2 into F12 into F13 into, what is the angle between them? 60 degrees. So I'll get it as root over F12 square plus F13 square. Cos 60 is anyhow 1 by 2. So I'll get it as F12, F13, guys. F12 and F13 both will be same in magnitude. So I'll get F square plus F square plus F square, which will be root 3 times of F. And what will this F value be, beta? Gm square divided by 2a whole square you will get, which is 4a square. So root 3 gm divided by 4a square should be the gm square divided by 4a square should be the force acting on one sphere due to the other two. I hope it is clear. Yes or no? Next case, if you see, if law of gravitational force becomes an inverse cube law instead of inverse square law. So they're saying gravitational force is inversely proportional to r cube. However, what will happen in this situation? Planets will move in elliptical path only. If the law of gravitational force becomes an inverse cube instead of inverse square law, motion of a stone, there will be no gravitational force inside a spherical shell of uniform density. Obviously, this will be correct only. Shell means there is no mass inside, no? The motion of a stone thrown by a person on the surface of the earth will be approximately parabolic now. So, how can we identify this? If the law of gravitation becomes an inverse cube law instead of being inverse square law, motion of a stone thrown by a person on the surface of the earth will be approximately parabolic. So if it is performing planet, so it will continue to perform elliptical motion. There will be no gravitational force inside a spherical shell of uniform density. Yes, because there is no mass inside means obviously there will not be any. Third one is correct. Okay. Planets will continue to move in elliptical orbit. So suppose this will provide necessary centripetal force if I say, guys. So I can write centripetal force to be proportional to r cube. So I can write v square by r will be inversely proportional to r cube. So I'll get v square will be inversely proportional to r square. So v will be inversely proportional to r. We can tell about the speed again. Speed will be inversely proportional to r. It means rv will remain constant again. Yes or no? So gravitational force is inversely proportional to r cube. Means v square by r will be inversely proportional to r cube. V will be inversely proportional to r. V square will be inversely proportional to r square. Will be inversely proportional to r. Rv will remain constant, guys. This is correct again. So Rv is constant means planet will continue to still move in elliptical orbit. This is also correct only. Motion of a stone thrown by a person on the surface of the earth will be approximately parabolic. How will it be parabolic? Second one will be wrong. There will be no gravitational force inside us. It will continue to move. Motion of a stone thrown by a person on the surface of the earth will be approximately parabolic. Thrown by a person on the surface of the earth. No, it will still follow straight. If it is throwing vertically upwards, it will follow a straight line motion only. It will not be following a parabolic path. We are in some ambiguity here. Planets will continue to move in elliptical orbits will be correct statement. There will be no gravitational force inside a spherical shell of uniform density. Now, are they asking, is it solid sphere or not? Okay, I'll just cross check the question, guys. See the last question. The satellite is orbiting very close to the surface of Earth. So here, the speed of the satellite with respect to Earth is v naught. A particle is to be projected from the satellite to just escape from the field of the Earth. Satellite is revolving. So from close to the Earth means g value will be g only, no? Yes or no? It is close to the Earth means smaller value will be equal to capital R only. So what will be escape speed from the satellite? It will be same as that of escape speed from the Earth only. So system should be projected with will be equal to escape speed only, guys. I think so. I'll just cross check this question also. See, if satellite is orbiting close to the Earth, small r value will be capital R only. Close to the Earth, g will be g at surface only. So from satellite, what will be escape speed? Root over 2, same as the dot speed at the surface again. So I think it should be equal to VE. So I'll just cross check this question also. Okay. So this was regarding gravitation, guys. It's a long session. We have tried to discuss both the problems as well as the concepts of or a review of gravitation. I'll just cross check one question. We were not able to do one question. So I'll just cross check that particular question. Okay. If possible, I'll take the class in the evening. We will talk about units and measurement. Right. Hopefully, we'll try to complete units and measurement also in the evening if possible. I'll let you know by 5 o'clock, something like that, guys. Okay. And what all doubts are still pending from my end, I will share them. Okay. Here, all of you. Right. So we'll be meeting in the evening if possible, guys. If not, tomorrow, probably at 7 o'clock or something like that. I'll let you know. Right. Till then, take care, everyone.
So,
Yes.
so could you solve that question, sir?
Which question you want me to solve?
Sir, the one which I have sent right now. Sir.
Currently, I have not received any question from you, no?
Sir,
Checking
I
I
have-
got. Which one? So many questions are there.
Sir, the first and second one are statement questions, sir. I mean,
How come there are no statements in the questions that you have given?
so the two particles A and B moving with a
Huh,
that one,
their position vector should be same. Position vector of one particle with respect to other should be equal to velocity vector of one particle with respect to other. Both of them direction should be same. So you will get second option as the answer for that. When will they collide? When will one particle collide with the other particle? Suppose if I have two particles like this, they are moving. When velocity of one particle is along the position vector. Yes or no? Suppose if I say two particles are there like this, position of this particle with respect to this, it is in this manner. Now, when will this object go and collide? If the velocity is along the position vector, no?
yes, sir.
So second option you will have. Both should have same direction. Position vector as well as velocity vector should have same direction. Direction is same means their unit vector should be same. So what all questions have been sent, I'll share the answers for you people separately, guys. Okay, because we are almost closing to almost 3.5 hours now, right? And chalo, we'll meet in the evening if possible. Okay. Any doubts in gravitation, all of you? Right. So we'll try to meet in the evening and do units and measurement, guys. Okay. Till then, take care, everyone. Thank you all. Bye bye, all of you. I'll extend the class time. Sorry, not class time. Hemant, I will extend that at least by evening. You do, huh? Probably till evening. I'll extend. I'll notify in the group. Okay. Thank you all. Take care.
Thank you, sir.
Thank you.